Mr. Clelland for Clelland Maths. This is your Ultimate Higher Maths 2026 exam prep video. Goes through every single topic, question by question by question. This has been massive. Hopefully you find this useful. Remember, you can study on the app.clellandmaths.com. I've dropped all the questions in there and the PDF if you want to follow along. I've also got my upcoming last-minute live streams the night before the exam. YouTube members only. Just join now. I've also got some bonus study sessions for members only during Easter. So if you want to join early, this is now the chance to do it. Take care. Hopefully you find this useful. See you soon. Clelland Maths is sponsored by Lecky, the educational publisher for Scotland. Today we're going to look at practice workbooks for National 5 and Higher Maths. These are just £5.59 when you use the discount code Clelland Maths at leckyscotland.co.uk, and these are excellent because they have lots of questions topic by topic by topic. So as you're working through the year, you can revise and practice any topic you want and make sure you are comfortable with that topic. But also when it gets towards exam season, a practice exam paper right at the end to make sure you're ready for your exams. Just £5.59 when you use the discount code Clelland Maths. The links are in the description and down below. SQA Higher Maths 2025, Paper 2, Question 1. The triangle ABC has these vertices. Find the equation of the altitude, then the median, then the point of intersection. Fairly standard stuff here. Altitude for B, it says. So there's B there. So my altitude is at right angles to AC. So I need the gradient of AC. So for part A, the gradient of AC is minus 24 minus 14 all over 21 minus 9. Use a calculator anytime you want, but that is minus 24 plus 14 is minus 10 over 30, which is minus a third. So that means the gradient of our perpendicular is equal to 3 as m1, m2 equals minus 1. And then the point I'm using is B, which is 920. So y minus 20 equals 3x minus 9. Y minus 20, 3x minus 27 then. So y equals 3x minus 27 plus 20 is minus 7. And we're done there for part A. Part B, the equation of the median for A. So a median cuts the opposite side at, well, 50-50. So I need the midpoint of BC. So I've got 920. B is 920. And C, I think, was 21 minus 24. So the mid of BC, 9 plus 21 divided by 2, and 20 minus 24 divided by 2. 9 and 21 is 30, so that makes 15. 20 minus 24 is minus 4, so that makes minus 2. So we get 15 minus 2 as our midpoint. So now we need the gradient between A and M because we're needing to go from here to here, which is M. A is minus 9 minus 14. So the gradient between, let's call midpoint M, the gradient between A and M is y2 minus y1. So I'll just do minus 14 minus 2 over minus 9 minus 15. Minus 14 plus 2 is minus 12. And minus 9 minus 15 is minus 24, which leaves a half. So then use a point A for A and B. I'll just use this one. Y minus 2 equals a half x minus 15. Take the 2 up then. Y plus 2 equals x minus 15. So we've got 2y plus 4 is x minus 15, or 2y minus x equals minus 19. And that's an acceptable way to leave it. You can leave it as y equals if you want, which might be handy for this question, but I'm not going to. I'm going to do it a different way. So question C, find the point of intersection between the median and the altitude. I've got two equations, y equals 3x minus 7. And I've got 2y minus x equals minus 19. Lots of ways to solve this. You could sub the y in for x here. You can make y here and then make them both equal, or you can do it like National 5 Maths. I'm going to do it like National 5 Maths because I've got a feeling a lot of us would. So I've got y minus 3x equals minus 7 for the first one, and 2y minus x equals minus 19. So I can just times the top one by 2, say, to get 2y minus 6x equals minus 14, and 2y minus x equals minus 19, and then just take away because the signs on the y are the same. What's your signs here? Minus 6x minus minus x is minus 5x, and minus 14 minus minus becomes plus. So it's minus 14, add 19. 19 minus 14 is 5. So therefore x is minus 1, and then we just sub into one of our equations. Well, we already had y equals 3x minus 7. So that's just 3 times minus 1 minus 7 minus 3 minus 7 is minus 10. Our point of intersection is minus 1 minus 10. And we're done there. SQA Higher Maths 2025 Paper 1 Question 2. Find the equation of a perpendicular bisector between 1, 4 and 9, 10. So perpendicular bisector means you need to find the midpoint first and then use m1 times m2 equals minus 1 for your gradient. So let's do midpoint of a and b. So that's when you add the points and divide by 2. Average them out. 1 plus 9 over 2 and 4 plus 10 over 2. 1 plus 9 is 10, so that's 10 over 2 and 14 over 2. That gives me 5 and 7. So there's my midpoint, and then I want my gradient of a and b. So 10 minus 4 on the top and 9 minus 1 on the bottom. 6 over 8, which simplifies to 3 over 4. So we can say that the gradient of our perpendicular is equal to minus 4/3 straight away, because m1, m2 equals minus 1. So we've now got our point, 5, 7, and our gradient, minus 4/3. So once again, y minus b is mx minus a. So then we can just take the 3 up, equals minus 4x minus 5, 3y minus 21, minus 4x plus 20. Now you can't really leave it like that, so I'll take the x's to the same side and take the numbers to the same side, so you get 41. That's one option, or you could have 3y plus 4x minus 41 equals 0. Or really, if you really wanted to have y equals, it would be minus 4 over 3x plus 41 over 3. I probably wouldn't bother leaving it like that. And we're done there. Higher Maths 2019 Paper 1 Question 7 had this one. The line makes a 30 degrees angle with positive direction of the x-axis. Find the equation of the line perpendicular to it, passing through 0, minus 4. So looking at the line L, the gradient is equal to the tan of 30. So the gradient of that is 1 over root 3 because it's an exact value. Now we can work out the gradient of our perpendicular. So the gradient of our perpendicular is equal to minus root 3 since m1 times m2 equals minus 1 because of perpendicular gradients. And then we can use our point. So I'll call that a and b. Y minus minus 4 equals minus root 3 x minus 0. Y plus 4 equals minus root 3x. Or y equals minus root 3x, take away 4 would be fine as well. And we're done there. SQA Higher Maths 2015 Paper 1 Question 9. ABC are points such that AB is parallel to the line with the equation y plus root 3x equals 0, and BC makes an angle of 150 degrees with the positive direction of the x-axis. Are they collinear? So you need to know what collinear means. They are all in a straight line. So if you work out if A to B are parallel and B to C are parallel, and when it says B is a point in common, they would be in a straight line because they're parallel or not. So let's just work on this. So the first part is to work out the gradient of AB. So for A to B, we have got y equals minus root 3x. So the gradient of that section is just minus root 3. For B to C, well, gradient equals tan theta because we've got the angle 150 degrees. So our gradient is equal to the tan of 150. Now, 150 is going to be an exact value. If you've got a cast diagram, we can see it's related to 180 minus 150. So if I work out the tan of 30, the tan of 30 degrees is 1 over root 3. But 30 degrees is positive here and here. So that's 180 plus 30, which is 210. And that's 180 minus 30, which is 150. Here, tan is negative. So the tan of 150 is minus 1 over root 3. And then we can just make a little statement. Since the gradient of AB doesn't equal the gradient of BC, the points are not parallel. And so they're not collinear. Not parallel, so not collinear. Now, if they were equal, you would then say they are parallel, but since B is a common point, they're collinear. SQA Higher Maths 2023, Paper 2, Question 1. Triangle PQR has these vertices. Find the equation of the altitude from P. Well, what they're drawing in is a right angle, so if I can find the gradient of QR, I'll know the gradient of the perpendicular. So part A, the gradient of QR. I've got 3 minus 8 on the top over 13 minus 2, y2 minus y1 over x2 minus x1. 3 take away 8 is negative 5. 13 minus 2 is 15. That gives me minus a third. And therefore, the gradient of the perpendicular must be 3, since m1 times m2 equals minus 1. And you always need that statement. So now we can use the point P to get the equation. So P is 5 minus 1. So I can use y minus b, my minus 1 equals 3x minus 5. So y plus 1 is 3x minus 15. And therefore y must be 3x minus 16. And we're done there. Part B, calculate the angle beside PR makes for the positive direction of the x-axis. Well, we know that gradient equals tan theta. So we need the gradient of PR. So let's look at P and R. We've got R, 3 minus 1 on the top, over 13 minus 5 on the bottom. That gives me 4 over 8, which is 1/2. So our tan theta equals 1/2. So the inverse tan of 1/2 equals, using a calculator, you get 26.565 or 26.6 degrees. And we're done there. SQA Higher Maths 2024, Paper 1, Question 1. A line passes through the point 0,4, makes an angle of 30 degrees with a positive direction of the x-axis. Determine the equation of the line. Oh, that's nice and simple to start with. Gradient equals tan theta. And it is the positive direction, so it's just tan 30 degrees. And an exact value triangle will help with this. 60 and 30. 2, 1 and root 3. So tan 30 is opposite over adjacent, 1 over root 3. So now I've got the point on the y-axis, so I can just use y equals mx plus c, because I've got c is 4. Mx plus c, so y equals 1 over root 3 x plus 4, and we're done there for question 1. SQA Higher Maths 2025, Paper 2, Question 9. A sequence satisfies the recurrence relationship un plus 1 equals mun plus 4, and m is a constant. The sequence approaches a limit as 10 as n goes to infinity. Determine the value. I'm still going to say that the limit exists implies that minus 1 is less than m is less than 1. I'm going to work at my m anyway. And then we've got L equals b over 1 minus a. So b is 4, 1 minus m, and that equals 10, it says. So solving that equation, 10, 1 minus m equals 4. That's 10 minus 10m equals 4. So minus 10m equals 4 minus 10, which is minus 6. So m is minus 6 over minus 10. Simplify that, minuses disappear, minuses cancel, then we divide by 2. 6 divided by 2 is 3, 10 divided by 2 is 5. So there's our m. Part B, u1 is 19, find u0. So un plus 1 equals 3/5 un plus 4, and u1 equals 19. So we can just say that if we had u1 here, it would give me u2. If I've got u1 here, it will give me u0 here. So we can just say that 3/5 u0 plus 4 equals u1, which is 19. So 3/5 u0 equals 15. So 3u0, u0 is 75, 5/15. So u0 is 75 over 3, which is 25. And we're done there. SQA Higher Maths 2024, paper 1, question 2. A sequence is defined by recurrence relationship. Un plus 1 is a fifth, un plus 12, and u1 is 20. Calculate the value of u2. Okay, so u2 is a fifth, u1 plus 12, but u1 is 20. So that's a fifth times 20 plus 12. A fifth of 20 is 4. 4 plus 12 then is 16. And we're done there. Part B, I. Why does it approach a limit as n goes to infinity? Because minus 1 is less than a fifth, which is less than 1, therefore the limit exists. Part 2, calculate this limit. Well, I use b over 1 minus a. So that is a and that is b. So that's 12 over 1 minus a fifth. That's 12 over 4/5. That's 12 times the reciprocal of 5/4. 12 divided by 4 is 3 times 5 equals 15. And we're done there. SQA Higher Maths 2019, paper 2, question 4. It says, in a forest, the population of a species of mouse is fallen by 2.7% a year. To increase the population, scientists plan to release 30 mice into the forest at the end of the year. It says UN is the estimated population at the start of April, n years after the population is first estimated, and it knows that UN and UN plus 1 satisfy this recurrence relationship. State the values of A and B. So for part A, it's really about pulling out the information from the question. So let's have a look at this. We have got it's falling by 2.7%. So to work out A is going to be the percent times UN, but what's left over? So it's 100% minus 2.7%. That gives me 97.3%. So A is equal to 0.973. And then B, we plan to release 30 mice into the forest at the end of each year, so B is 30. And we're done there. Question B. Explain why the estimated population of mice will stabilize in the long term. So it mentions stabilizing, so it means a limit exists. So we can say a limit exists since minus 1 is less than 0.973, which is less than 1. And that's all we need to say. Step 2, calculate long-term population of nearest 100, and now let's find the limit. So for part 2, L equals B over 1 minus A. So we'll just plug our numbers in. B is 30, then it's 1 minus 0.973. 30, over 0.027, which is 111.11, 111.11, or to the nearest 100, 1100. And we're done there. SQA Higher Maths 2019, paper 1, question 4. A sequence is generated by UN plus 1 is m, UN plus c, where the first three terms are 6, 9, 11. Find the values of m and c. So we have got 6, 9, and 11. So we could call that the first term, the second term, and the third term. So the second term would equal m times the first term plus c. And the third term would equal m times the second term plus c. So we can just sub them in. So u2 is 9, is equal to 6m plus c. And u3 is 11, that equals 9m plus c. Simultaneous equations to solve. So we can just do 2 take away 1. That gives me an 11 take away 9 is 2 is equal to 3m. So m is 2/3. Sub that in, we get 9 is equal to 2/3 times 6 plus c. 6 2s are 12 divided by 3 is 4. So 9 is equal to 4 plus c, and therefore c is equal to 5. It then says part B, calculate the fourth term of the sequence. So for part B, u4 is equal to m, which is 2/3, times u3 plus c, which is 5. And u3, remember, the third term was 11. So that equals 2/3 of 11 plus 5. So 11 times 2 is 22 over 3. So I might as well make the 5 15 over 3. So we've got a common denominator. 22 plus 15 is 37 over 3. And if that's already simplified, I'll be done. Well, it is simplified, so I'm done. SQA Higher Maths 2015, paper 2, question 3 had this long one. It says a version of the following first appeared in print in 16th century. Who disagree with who cares? A frog and a toad at the bottom of a well is 50 foot deep. Each day the frog climbs 32 foot, rests overnight. During the night it slides 2/3 of its height above the floor of the well. The toad climbs 13 foot before resting, then it slides a quarter of its height. So we need to see what this question is asking us, but it gives us two recurrence relationships. It says the progress can be modelled by this. F of n plus 1 is a third f of n plus 32, and the first term is 32. And then for the toad, tn plus 1 is 3/4 tn plus 13, with the first term is 13. And it says f and t are the heights reached by the frog and toad at the end of the nth day after falling in. Part A, calculate T2, the height of the toad at the end of the second day, only worth 1 mark. So to calculate T2, you just sub in T1. So let's just go ahead and do that. So for part A, T2 is going to equal 3/4 of T1 plus 13, but we know that T1 equals 13. So therefore we can just say that T2 is equal to 3/4 times 13 plus 13. Nice and simple there. Well, this was a calculator question, so we just do 13 times 3 is 39, divide that by 4 and add 13, and we get 22.75. Okay, part B of the question says, determine whether or not either one will eventually escape the well. Now this seems to be like, well, what's this asking me? Whenever a question says, basically, will something happen after a certain amount of time and it's to do with recurrence relationships, it's asking whether it's got a limit or not, okay? So if you understand that when a sequence has a limit, you'll be fine. Now, a sequence has a limit when A, the number in front of here, f of n or t of n in this case, is between -1 and 1. So let's just save that. So for part B, if we look at our frog first of all, that is f of n plus 1 is a third f of n plus 32. Let's just write that down. We can say that a limit exists because -1 is less than a third is less than 1. So limit exists since -1 is less than a third, which is less than 1, and we can calculate that limit. So the limit, remember, is equal to b over 1 minus a, where that's my a and that's my b. So that equals 32 over 1 minus a third. And since it's a calculator question, you can just do that in a calculator, or without a calculator, that's 32 over 2/3. Now I'll just do it without a calculator just to show you how. So L would equal 32 times 3/2. Divide by a fraction times by its reciprocal. 32 divided by 2 is 16. 16 times 3 is 48. So the limit, or in other words, where the frog will reach, will be 48. Now 48, we know the well from the question is 50 feet, and therefore the frog will never escape the well. So therefore the frog will never escape the well as 48 is less than 50. And then we can do the same thing for the toad. So let's look at our toad. His recurrence relationship was Tn plus 1 is 3/4, Tn plus 13. So the limit exists since minus 1 is less than 3/4, which is less than 1, and we can calculate that limit. L equals b over 1 minus a, which is 13 over 1 minus 3/4, which again, you can just use your calculator to work this out, but that is 13 over a quarter. 13 over a quarter is the same as 13 times 4 over 1, so that is 52. So we can then say the toad escapes the well since 52 is bigger than 50. And we're done there. SQA Higher Maths 2025, Paper 2, Question 4. The function g is defined as g of x is x minus 4 cubed. Find the inverse function. There's two ways to do this. I'll show you both if you fancy. So the first method is the way I prefer nowadays, which is to say that g of g inverse of x equals x. So if you just sub in inverse of x, inverse function into x, you'll get it. So that gives me x becomes inverse function of x minus 4 all cubed equals x, I'm saying. So I need to get rid of that cubed, so I can say the inverse function of x minus 4 just equals the cube root of x, and then I've got it. Inverse function of x equals the cube root of x plus 4. And we're done there. Let me show you the alternative method. The alternative method is, let's start with our function again. G of x is x minus 4 cubed. You say let y equal x minus 4 cubed, and we make y x the subject. So the cube root of y is x minus 4. The cube root of y plus 4 equals x. And then immediately you just say then inverse, it's not f, it's g in this case. The inverse function of x is the cube root of x plus 4. But be careful with this method. Don't ever change that to a y again because you'll lose a mark. And you may need a statement at the start. I never use this method. I prefer this method nowadays. I think it's cleaner. SQA Higher Maths 2024, Paper 2, Question 8. Functions f and g are defined on R, the set of real numbers by 2x squared minus 18 for f of x. G of x is x plus 1. Find an expression for f of g of x. F of g of x, you usually get a mark for substitution. So it's 2 g of x squared minus 18, just to show that. G of x is x plus 1. So you just go straight to this step if you want, minus 18. Now I think you'll get all the marks for that. You don't need to do anything else. And the way I've solved this, it's handy to have it like that. But in case anyone did multiply it out, I'll multiply it out. 2x squared plus 2x plus 1 minus 18. So that gives me 2x squared. 2 2's is 4x. 2 1's is 2, but 2 minus 18 is minus 16. So either of them should be fine. Question B says, find the values of x so that 1 over f of g of x is undefined. Well, that means that you can't have that bottom bit being 0. So that means that you could say that f of g of x cannot equal 0. So I want to find the numbers which make that happen. So I'll just make it equal to 0 and see what I get. So you've got 2x squared plus 4x minus 16 equals 0. But notice at the start, that was in completed square form. So you can start from that point and probably solve it a lot quicker. Or you can start from this point. Since I'm here now, I'll just do that anyway. So I've got 2 bracket x squared plus 2x, and I've got minus 8 equals 0. So that's 2 double brackets. Let's hope it actually factorises in if we're doing it this way, because I would do it another way. I think it's going to be 4 and 2, is it? Okay. And I want plus 4 minus 2. Okay. So I've got x equals 2, x equals minus 4. So you just say undefined when x equals 2 or x equals minus 4. Find the values of x, so it's undefined. Undefined when? You could actually answer the question by saying that if you wanted to say what the range is, you could say that x is a member of R and x cannot equal minus 4 and x cannot equal 2. But really, we're saying what values for x is this undefined. So if it's undefined when x is equal to 2 and x equals minus 4 is actually the answer. Now, going back up, if you'd done it from completely square form, just as a kind of side note this, 2x plus 1 squared minus 18, this is the power of completing the square. That means that I can take the 18 over, 2x plus 1 squared equals 18. And that means that x plus 1 squared equals 18 over 2 is 9. I can just square root both sides. That gives me x plus 1 equals plus or minus 3. So x equals, when it's plus 3, 3 minus 1 is 2. And when it's minus 3 minus 1 is minus 4. And you would get the same thing. And there we are. SQA Higher Maths 2025, Paper 2, Question 12. Functions f and g are defined as a set of real numbers by that. Find an expression for h of x, which is f of g of x. Okay, part A, f of g of x means in f, put in g every time you see an x. So f says x to the power of 5. So that is g of x to the power of 5 plus 3. What is g of x? 1 minus x cubed. So I put 1 minus x cubed here. That's to the power of 5 plus 3. There's not much else I can do with that because it's spanning a fifth bracket beyond us. So we've got 1 minus x cubed to the power of 5 plus 3. Now part B says find h dash x. So it's differentiation then. Well, chain rule. 5 comes down to the front. 1 minus x cubed stays where it is, and I take away 4. The 3 is going to disappear, of course. And now I need to break the chain. 1 minus x cubed, I need to differentiate it. So x cubed becomes 3x squared, and it's a minus. So it's times by that. 5 3s is 15, so minus 15x squared. 1 minus x cubed to the power of 4. And we're done there. SQA Higher Maths 2023, Paper 1, Question 13. Two functions f and g are defined as f of x is 2 sine x for between 0 and pi over 2, and g of x is 2x for between 0 and pi over 4. Evaluate f of g of pi over 6, and then find an expression for f of g of x. So we might as well do the first one direct instead of going f of g of x first, but you could have done that first and then subbed it in. So for part 1, I want f of g of pi over 6. Well, g of pi over 6 is simply 2 times pi over 6, because g of x is 2x. That is pi over 3. So f of g of pi over 6 is just simply f of pi over 3. F is 2 sine x, so it's 2 times the sine of pi over 3. So the sine of pi over 3 is an exact value. If you don't know it, pi over 3 is 60 degrees, so I've got 60 degrees here. I've got, I think, an equilateral triangle, so it goes 2, but it's been cut in half 1, and that's root 3. So the sine of pi over 3, opposite over hypotenuse, is root 3 over 2, so that's 2 times root 3 over 2, which is just simply root 3 as our final answer. Part 2, determine expressions for f of g of x. So f of g of x is equal to f of, well, g of x is 2x. So that is 2 sine 2x. 2 sine 2x. And we're done there. Part B, given that f of p is a third, determine the exact value of sine p. So f of p, part B1, f of p is just going to substitute p in, 2 sine p. It's told us in the question that f of p equals 1/3, and therefore sine p is equal to 1/3 divided by 2, which is 1/6. Part 2, hence determine the exact value of f of g of p. So B part 2, f of g of p. Well, f of g of x is 2 sine 2x, so f of g of p is 2 sine, just change it to a p. So 2 sine 2p, well sine 2p is 2 sine p cos p from the start of exam paper. So it's 2 times 2 sine p cos p, which is 4 times sine p cos p. Now I don't know sine p is a sixth. So if sine p is a sixth, if I draw a little right angle triangle and call that p, opposite's 1, hypotenuse is 6. So I can do Pythagoras, 6 squared minus 1 squared, 36 minus 1 is 35. So that side is the square root of 35. So this gives us 4 times the sine of p, which is a sixth, times the cos of p, which is going to be adjacent of hypotenuse, which is root 35 over 6. You may be wondering, is root 35 a simplified surd? Well, 4 doesn't go into it, 9 doesn't go into it, 16 doesn't go into it, 25 doesn't go into it. So no, it's already simplified. So when we just times the top, 4 root 35, times the bottom, 36. Simplify with 4 and 36 to get root 35, 4 nines are 36. Doesn't look simplified, but it actually is. There's nothing else you can do with that, so we're done. SQA Higher Maths 2024, paper 1, question 5. Function h is defined as h of x is 2x cubed minus 7. Find the inverse function h minus 1x. So I'll just start with y equals 2x cubed minus 7. Make x a subject. Y plus 7 is 2x cubed. Y plus 7 over 2 is x cubed then. So y plus 7 over 2 cube rooted equals x. But don't switch them back. So you just now straight away go into the inverse function of x equals now switch back. Cube root x plus 7 over 2, and we're done there. SQA Higher Maths 2023, paper 2, question 6. A function f is defined as f of x equals 2 over x plus 3 for x greater than 0. Find the inverse function. So what I usually do with these is I write y equals 2 over x plus 3. Well, there's other ways to do these. And make x the subject. So taking away 3, I get 2 over x. Multiplying each side by x, I get x bracket y minus 3 equals 2. And dividing through by y minus 3, I get x equals 2 over y minus 3. So then I immediately write down my answer. The inverse function of x is equal to 2 over, now just x minus 3. Make sure you do not write at any point swapping these back to y and x, because then you'll get an inconsistent answer and you'll lose a mark. Inverse functions, SQA Higher Maths 2016, paper 1, question 6. F and g are defined in the real set of numbers and the inverse functions both exist. Part A, if f of x is 3x plus 5, then the inverse function of x. So for part A, I can just write y equals 3x plus 5 and make x the subject. So that means that y minus 5 equals 3x. And therefore y minus 5 over 3 equals x. Don't now be tempted to write y equals x minus 5 over 3 or you'll lose a mark. Just go straight into therefore the inverse function of x equals y becomes x, so x minus 5 over 3. And we're done there. Part B of g of 2 equals 7. What is the inverse function of g of 7? Right, that sounds a bit strange, but this relies on you knowing what this means. If I put in 2 and I get 7, then that means that if I put in 7 in the inverse, that takes me back to 2. So that just means the inverse of 7 is just 2. There we go. SQA Higher Maths 2025, paper 1, question 5. The diagram shows the graph of f of x with stationary points at 0, 3, 4, 0. And on the diagram in your answer booklet, sketch the graph of f of minus x plus 3. Now, this is where I think some people will make a mistake. The minus is not in front, so it's not flipping that way. The minus is stuck here, which means we're flipping that way. It's a y-axis flip, then add 3. So looking at our points, let me just draw a graph for this. Got a y-axis and an x-axis. So looking at minus 2, if that goes over the y-axis, it becomes 2, but then I need to add 3, so it becomes 2, 3. So I can just note a point, 2, 3. Looking at 0, 3, well, when you flip it on the y-axis, it's still 0, 3, but I'm adding 3, so it's plus 6, 0, 6. So I can just put 0, 6 up here. And then the last one, 4 is going to flip over to be minus 4, but then I need to add 3, so it's somewhere over here. Just draw that nice and neat. Minus 4 add 3 will be in line with 2, 3. So probably somewhere about there. It's probably not to scale that, so what I'll probably do is move it out a little bit to put it over there and just make my axis a bit bigger. Minus 4, 3. But you get the idea. Now you just draw it in, watching where the turning points are. So 0, 3 was that one. So that's 0, 6. So that's that side. And then this one was the 4, but it became minus 4. So there's my turning point there for that bit. Connecting up to here, turning back round, and just going down. Now you can't quite tell where it cuts the x-axis, so that's fine. Now my curve's a bit messy there, so I'm just going to neaten that up. But other than that, that's it. So just a nice neat curve if you can. And that's a little bit better. But well done there. SQA Higher Maths 2024, paper 2, question 4. The diagram shows the graph of a quadratic function. Wow. The maximum turning point occurs at minus 1, 3. The graph of y equals f of x has a point of inflection at x equals 2. And always a turning point that doesn't turn, keeps going down. And determine the coordinates of the maximum turning point of the graph of y equals f of x minus 4 plus 2. Well, the turning point to start with is minus 1, 3. So we're starting with minus 1, 3. Now this bit here, the bit that says x minus 4 means a shift to the right by 4. So I'm going to go right by 4. And then the bit at the end, plus 2, up by 2. So that becomes minus 1 shifts to the right. Minus 1 add 4, that gives me 3. 3 goes up by 2, that gives me 5. 3, 5, job done. Part B. In the diagram in your answer book, sketch a graph of the derivative, y equals f dash x. So I've got a method for this, and this is my method that I use. I do this as if I'm doing a nature table, basically. And I'm going to say that's my derivative. And I'm going along to the turning points, because the turning points on the graph of the derivative turn into roots, because the 0 gradient. So the first turning point is minus 1. And then we go along and we get another turning point at 2. And then we go along. And then we just examine what happens before and after this turning point. So checking my graph. I'm going up the way, so that's positive. Then I'm going down, that's negative. And then I'm going down again, that's negative. So it's positive, negative, negative. So I can just write that. So the first one is positive, that's 0, negative, that's 0, and negative. So in terms of thinking about where I'm drawing this, I'm drawing that above the x-axis, on it, below it, on again, and then below. So then what you do is you get your diagram. Now I've not got one because I've not got an answer book yet, because I'm not a student. So I'll just draw it by hand. X and Y. You put your turning points on as your roots, minus 1. Let's just call that 2. And I'm thinking I'm above before minus 1, so I'll just put a wee mark, just to remind me. And then I'm below after minus 1. And then I stay below. And then I need to go back up here and then go down a low. So that must be a turning point that I just touch and hug. So we can just kind of think of this as we're going to go down. We need to go up at some point, and then we're going to go back down. So that looks like a decent graph, and we're done there. SQA Higher Maths 2023, paper 1, question 9. The diagram shows the graph of function f of x is log base 3x. X is greater than 0, of course. The inverse function does exist. In the diagram in your answer book, draw the graph of the inverse function, minus 1. Well, let's examine the inverse function first. The inverse function of a log is an exponential. And essentially, the easiest way to draw it, imagine a dotted line here, y equals x. The coordinates just switch places, okay? So here is my normal y equals x. So 1, 0 becomes 0, 1. And 3, 1 becomes 1, 3. And it just gives you an exponential curve. And that would be 1, 3. So that's the inverse function of x. So now I just need to take away 1, which means just to move it down by 1. So 1 is going to go to 0, and 1, 3 is going to go to 1, 2. So I can just draw it now. There's 0. It's obviously going to drop below because that's where your asymptote is, essentially. So it's going to go along, up through 0, and start climbing. And we just put that point on that we noted, which was 1, 3. So it now becomes still 1, but 2, and we're done there. SQA Higher Maths 2025, paper 1, question 6. The diagram shows a right angle triangle with angle at Q. Find sine 2Q cos 2Q. We have a second right angle triangle, so we have to do sine 2Q minus R. So sine 2Q is 2 sine Q cos Q. So I'm going to have to know sine Q and cos Q, so I'm going to have to do Pythagoras. 5 5s is 25, 1 1s is 1, that's 26, so that's root 26. So we get 2. The sine of Q is 1 over root 26. And the cos of Q is 5 over root 26. That's a root. 2 times 5 is 10, and 26 rooted times 26 rooted is just 26. Half each of the numbers to get 5 over 13. And we're done there. I'll do part B underneath because I don't want to get too messy. Part 2, cos 2Q. Well, there's 3 things at the exam paper, but I'm just going to use 2 cos squared Q minus 1 because it's the easiest one for me to use at the moment, I think. So cos Q we already have worked out is 5 over root 26. So that's 2 5 over root 26's squared minus 1. That gives me 2 times 5 5s is 25 over 26 minus 1. 2 times 25 is 50 over 26 minus, well, 26 over 26, which is 50 minus 26 is 24. And that will be simplified to a half of 24 is 12 and a half of 26 is 13. The last bit says find the value of sine 2Q minus R. Let me just copy that down. So again, start of exam paper, angle formula for addition. We've got sine 2Q cos R minus cos 2Q sine R. Well, sine 2Q we worked out up here was 5 over 13. So that's 5 over 13. Cos R, well, I can just work that out. Opposite over adjacent over hypotenuse. Adjacent over hypotenuse is 4 over root 17. Minus cos 2Q I worked out here was 12/13. And sine R is 1 over root 17. So that gives me 5 times 4 is 20, 13 root 17s minus 12, 13 root 17s, which is 1 fraction is 8 over 13 root 17s. And I think we'll be happy that that is the answer. You could probably take it a step further and rationalise the denominator, but I don't really think that you would have to in this case, but I'll do it for the sake of completeness. If I was to do that, I would do 8 over 13 root 17 times root 17 over root 17. And that would just give me 8 root 17 over 13 times 17. That's 8 root 17 over 211, which is arguably not any simpler. So 8 over 13 root 17, I think, is where we're going to be stopping. SQA Higher Maths 2024, paper 1, question 6. A right angle triangle in the diagram is such that sine p is 1 over root 5, p is between 0 and pi over 4. Then the value of sine 2p, cos 2p, and then sine 4p. So I've got a right angle triangle, so I will do Pythagoras to get one of the sides. So I've got root 5 squared minus 1 squared. That's 5 minus 1 is 4. So I've got root 4 is 2. So now, expanding this, that's 2 sine p cos p. So what's cos p? Cos p is opposite, adjacent of hypotenuse, 2 over root 5. And we already know sine p is 1 over root 5. So that's 2 times 1 over root 5 times 2 over root 5 times in the top, 2 times 1 times 2 is 4, times in the bottom, root 5 times root 5 is just 5. So you get 4/5. Cos 2p, well again, using this exam paper, you can use any of the expansions you want, and the one I'm choosing to use is 2 cos squared p minus 1. But you'll get the same answer, I'm just using that because it's got a positive value. So that's 2 cos p is 2 over root 5. So I need to square that and then take away 1. So that's 2 times 2 2's is 4, root 5 times root 5 is 5, minus 1. 2 4's is 8 over 5, minus 1, which is 5 over 5. That gives me 3 over 5, and we're done there. Hence, determine the value of sine 4p. Now, sine 4p is like sine 2p. If sine 2p is 2 sine p cos p, then this will be sine 2p cos 2p instead of pp, because it's 4p instead of 2p. So then I can just substitute in 2 sine 2p. Well, I know sine 2p is 4/5, so I can just write 4/5. And I know cos 2p is 3/5, so I can just write 3/5. So that gives me 2 4's is 8, 8 3's is 24, over 5 5's is 25. And we're done there. Higher Maths 2015, Paper 1, Question 10, Addition and Double Angle Formulae. Given that tan 2x is 3/4, part A, find cos 2x. Right, okay, so part A, we know tan 2x is equal to 3/4. So that means we can draw a right angle triangle, and we could call this angle 2x. And opposite is 3 and adjacent is 4. By Pythagoras, 3 squared plus 4 squared is 5 squared. This is a standard Pythagorean triple. So we can immediately write down cos 2x because that is adjacent of hypotenuse, which is 4/5. So a simple 1 mark question there. Part B, we have to work out cos x. Well, we can't go from cos 2x to cos x directly. Don't be tempted to divide by 2. We need to expand cos 2x. So there's the start of the exam paper. There's a number of trigonometric identities. Pick the one you want. 2 cos squared x minus 1 would work. So I'm going to pick 2 cos squared x minus 1. And cos squared x is the same as cos x squared, remember. So we know cos 2x is 4/5, so we've set up an equation basically, because that equals 4/5. So that means that I can add 1 to both sides to get 2 cos squared x. Well, if I add 1, it's the same as adding 5/5, so 5 and 4 is 9. That gives me 9/5. So cos squared x dividing through by 2 is 9 over 10. And therefore cos x is the square root of 9/10. So I can write that down. Cos x is the square root of 9/10. Well, from the rules of surds, I can split that up into 2 square roots, the square root of 9 over the square root of 10. So that's 3 over root 10. Square root of 9 is 3, and root 10 is already a simplified surd. And we'll just define the exact value of cos x, so we've done that, so we're done there. Differentiating a trig function, SQA Higher Maths 2016, Paper 2, Question 11. Show that sin 2x tan x equals 1 minus cos 2x, and then differentiate sin 2x tan x. So part A, sin 2x tan x, well, we can change sin 2x to 2 sin x cos x, and we can change tan x into sin x over cos x. So that gives me 2 sin squared x, and the cos x obviously cancel. So then as an aside, remember we've got a cos 2x on the right hand side. Well, cos 2x, using the expansion with sin squared x in it, is 1 minus 2 sin squared x. So we can rearrange that to get what sin squared x is. That means that 2 sin squared x, moving over to the right, equals 1 minus cos 2x. As required. Part B, f of x is equal to 1 minus cos 2x now. So f dash x, differentiating each function, 1 goes to 0, Cos, remember, goes to minus sine, so it becomes plus sine, so it's sine 2x because of minus minus. And then we need to, because of a chain rule, differentiate the inner function, which is 2, so times by 2. So we get 2 sine 2x. SQA Higher Maths 2017, Paper 2, Question 11, Trigonometric Identities. Part A, show that sine 2x over 2 cos x minus sine x cos squared x equals sine cubed x. So the way to deal with these is just keep it separate, start dealing with the left and start making it equal to the right hand side. You may have to manipulate the right hand side separately as well, so you get two different things equal, but in this case, probably not. So let's look at the left hand side. We've got sine 2x, we can write that as 2 sine x cos x, just using the start of the exam paper, over 2 cos x. And then we've got minus sine x cos squared x. So we can cancel the 2's and we can cancel the cos x's from here. So that leaves just sine x for this one, minus sine x times cos squared x. Sine x is a common factor in this case, so that gives me sine x bracket 1 minus cos squared x, and if you're paying attention, you'll realise that 1 minus cos squared x is also equal to sine squared x. Just check the exam paper. Sine squared plus cos squared equals 1. So that means I can say that that is sine x times sine squared x, which is equal to sine cubed x, as required. Okay, part B, hence differentiate sine 2x over 2 cos x minus sine x cos squared x between 0 and pi over 2. So if we're going to differentiate that, we can just differentiate the right hand side because it's equal to it. So for part B, d by dx of the left hand side equals d by dx of what we just found out, sine cubed x. Now, sine cubed x, remember, means the sine of x squared. So it's easier to write it like that to see exactly what you're doing. So if I just write sine of x, that's to be cubed. So I have to differentiate sine x all cubed. So that's the chain rule. So the chain rule says I take the power down to the front, I leave the function alone, so it's sine x. And then I take 1 away from the power, so that's squared. But then I need to differentiate the inner function, which is sine x. Check the start of the exam paper, sine x goes to cos x, so times by cos x. Tidying that up, that's 3 sine squared x cos x. And we're done there. SQA Higher Maths 2024, Paper 1, Question 11. Express cos x plus root 3 sine x in the form k cos x minus a. And then we'll have to sketch a graph. Okay, let's start. So for part A, we've got cos x plus root 3 sine x equals k cos x cos a minus, so it becomes plus k sine x sine a. I mean, on the degrees signs, you can put them in if you want. So when we compare coefficients, in front of cos x, we've got k cos a. So k cos a equals 1. And in front of sine x, we've got k sine. And in front of sine x, we've got k sine a. So k sine a equals root 3. So to get our k, it's the square root of 1 squared plus root 3 squared. That's the square root of 1 plus 3 is 4, which is 2. Then we can say that tan a is sine over cos, root 3. So then we do the inverse tan of root 3. Oh, that's an exact value. 60, 30, 2, 1 root 3. That's 60 degrees. And now we need to check, is it that one? So cast diagram. Sine was positive and cos was positive, so it is 60. So our final answer is 2 cos x minus 60 degrees. And we're done there. So usually a cos graph, just to give you this idea, up here goes to 1 and minus 1, but this one goes to 2 and minus 2. And it's shifted to the right by 60. So if we're shifting to the right by 60, its starting position here is 60 degrees. And then usually here we're at 90. So we do 90 plus 60 is 150. And then usually here we are at 180, so we do 180 plus 60 is 240. And then usually when we come back up, we are at 270, so we do 270 plus 60, which is 330. And we'll just show 360 here. So we're starting here, and we're just going down there, along and up. And then we won't kind of get there, it'll kind of all starting. And this one you can see we're going there. Now you might be asking yourself, well, what about this point here? Could we work that out? Well, you actually can quite easily. The answer is 1. And the reason, I'm just going to put some of my numbers in, 60 degrees 2. And the turning point here is 240 degrees and minus 2. So to work that out is when x equals 0. So you've got 2 cos minus 60. Well, if you add 360, don't have to get back into a standard place, that's 300. So we want to know the cos of 300. Well, that's related to an exact value. Cast diagram, 300's here, so that means it's 60. So I just want a cos of 60. Well, the cos of 60 using that triangle up here is a half. So it's 2 times a half, which is 1. So that's why I can put 1 on there quite easily. So I've done that just to be on the safe side. But basically, there's your graph, and we're done there. SQA Higher Maths 2023, paper 2, question 9. Express 7 cos x minus 3 sin x in the form k sin x plus a, so the wave function. So let's start off with expanding this. You've got k sin x plus a. So from the start of the exam paper, that's k sin x cos a plus k cos x sin a. And then we're just equating the left-hand side with the right-hand side from the start of the question. So looking at, if I highlight this, what's in front of sin x? I've got k and cos a. And what's in front of sin x in our question? Minus 3. So I can say that k cos a equals minus 3. Similarly, using a different colour highlighter for clarity, in front of cos x is sin a and k, and in front of cos x in our question is just the number 7. So I can say that k sin a equals 7. So now we can find k. To find k, because sine squared plus cos squared equals 1, if I square both of them, I will end up with k squared. So k is going to be the square root of 7 squared plus minus 3 squared. A bit like Pythagoras, essentially. So that becomes 49. And 3 3s are 9. So k becomes the square root of 58. And we'd usually use an exact value if we can. And then, because sine divided by cos is tan, I can say that the tan of a is equal to minus 7 over 3, or 7 over minus 3. So I can now work on a. The inverse tan of 7 over 3 is 66.8 degrees. So cast diagram, but it's not the cast on tan, remember, it's the cast on cos and sine, because that's what you started with. So looking at sine first, that's positive. So that is A and S. And then looking at cos, that's negative. Well, cos is negative on S and T. So therefore, the quadrant we want is this one, which is 180 minus. So that means that A is 180 minus 66.8, which is 113.2 degrees. So we've got our A, we've got our K. So to answer the question, it is root 58 sine of x plus 113.2 degrees for our mark. Now part B. Hence or otherwise, find the maximum value of 14 cos x minus 6 sin x and the value where it occurs between 0 and 360. Well, notice 14 is double 7, 6 is double 3, so that is just double this. So I just need to double it. So I can say for part B, if I write it out, 14 cos x minus 6 sin x equals 2 times this, so 2 root 58 sine x plus 113.2 degrees. So for part 1, the max value, well, this is just a graphs question. It isn't a differentiation question. A normal sine graph goes up to 1 and minus 1, but it's been times by 2 root 58. So the max value is 2 root 58. Now we could simplify that by, well, not simplify it, we could have that as a decimal because you're using a calculator if you want, but 2 root 58 is fine. There's no square numbers that go into 58. Part 2, find the value of x for which it occurs. So this x plus 32 is 113.2 is telling you something. The sine x, its max normally appears at 90. If I just draw you a little graph, there's our normal sine graph there. And it goes to 1 and minus 1 usually, but for this one, it's going to go to 2 root 58 and minus 2 root 58. If this hadn't been shifted, this number here, its max, would be 90. But it's shifted to the left by 113.2 degrees. So all I need to do is do 90 minus 113.2. 90 minus 113.2 degrees gives me an answer which is negative. 90 minus 113.2 is minus 23.2 degrees. Well, that's no good because that's negative. I'm now in the left and I want it to be between 0 and 360. So to solve that is, remember, sine repeats every 360. So I'm just going to add 360 degrees and that will give me in the correct range 336.8 degrees, and we're done there. SQA Higher Maths 2025, paper 2, question 6. Express 5 cos x minus 9 sin x in the form k cos x plus a, where k is greater than 0 and a is between 0 and 2 pi. So we're working in radians because it mentions pi. And then solve 5 cos x minus 9 sin x equals 7 between 0 and 2 pi. Okay, so wave function first. 5 cos x minus 9 sin x equals k cos x cos a. Change the sign, k sin x sin a. So I'm now examining what's in front of cos x on both sides. Well, k cos a equals 5. And then similarly, in front of, say, sin x, well, it's minus k sin a, but it's a minus on both sides, so I can just cancel the minus straight away. So it's just k sin a is equal to 9. If you don't like that, you can just write minus k sin a equals minus 9, so k sin a equals 9. So we've got our two equations. To get our k, it's just Pythagoras. K is the square root of both the numbers squared and added. So that is 25 and 81. 81 becomes 86, 96, 106. So I've got my k. Tan a is sine over cos 9 over 5. So I do the inverse tan of 9 over 5 in my calculator, making sure my angle is in radians. Radians inverse tan 9 over 5 is 1.063697. So I think 1.064 is a reasonable place to stop. Check that it is actually a with a cast. I never skip this step. The sine equation was positive and the cost equation was positive, so a is 1.064. So that means a equals 1.064. So we've got root 106 cos x plus 1.064. And we're done there for part A. B says, hence solve 5 cos x minus 9 sin x equals 7 between 0 and 2 pi. Well, it's the same equation, so I'll just make that equal to 7. Root 106 cos x plus 1.064 equals 7. So divide by the root 106. And now do my inverse cos of 7 over root 106. As if it just says x, really. So again, make sure my calculator is in radians. Shift cos 7 over root 106 is 0.823. Cast diagram to get another answer before I take off the 1.064. So cost was positive. So I do 2 pi minus the answer. So I can do 2 pi minus 0.823. 2 pi minus 0.823 is 5.460. So two answers to start with, but they're not my answers. It's got x plus 1.064. So I say x plus 1.064 equals 0.823. X plus 1.064 equals 5.460. Solving that, x would be, not doing these sums in my head, 0.823 plus, minus 1.064 is 0.241, but we are minus. Now the answers are between 0 and 2 pi. So if you ever get outside that range, you just add multiples of 2 pi. So I'm just going to add 2 pi because I'm outside the range. And that'll get me inside the range of 6.042. By adding 2 pi, I get 6.042 for the first one. Doing the same for the next one, we've got 5.460 minus 1.064. That's 4.396. Now that is within the range. Pi is about 3.14, 2 pi is 6.28, 4.396 is nice in there. And I've not got multiple angles here like 2x or 3x, so I know I'm going to be done. So that's it. I've done my answers all right. I'm out nice and neat. X equals 4.396 and 6.042. And we're done there. SQA Higher Maths 2024, Paper 2, Question 12. Solve the equation, which is a trig equation, sine 2x, 2 sine 2x minus sine squared x equals 0. Let's expand that. So let's expand that. It's 2 times 2 sine x cos x minus sine squared x equals 0. So that's 4 sine x cos x minus sine squared x equals 0. That's a little bit tricky, that, because if you take sine x out as a common factor, you're going to get sine and cos in one of the brackets, and that's going to look really funky. So some of you might have been tempted to go sine squared plus cos squared equals 1, maybe not getting away with that, but there are other trig identities you could have used, and one of them is sine divided by cos is tan. So if I divide by cos, you're going to, in a minute, once I take a common factor out, you'll see what's going to happen. So that's the route I'm going to take. I'm going to take common factor out of, not 4 of course, just sine x. And I get 4 cos x minus sine x equals 0. So I've got sine x equals 0, easy enough there. And 4 cos x minus sine x equals 0. So I'm going to divide the whole of this by cos x, because if I do that, divide both sides by the same thing, as that's allowed, I'll get rid of the cos x from the first term, and I'll get a tan x in the second term. So there's not a bit of trick there. So I'm going to divide this side by cos x, and similarly this side by cos x to be fair. So cos x divided by cos x is 1, so that gives me 4. Sine divided by cos is tan, so that gives me tan x. 0 divided by cos x is 0, and therefore tan x equals 4. And now I can solve both my equations. Inverse sine is 0. Well, you should know that. You need a calculator for that, but let's just check. There's your graph there. And we're in radians or not? Nope. So you've got 0, 180, and 360. Now be very careful here. X for this is equal to, the limit is between 0 is less than or equal to x, so 0 counts, but then less than 360, so 360 doesn't count. So it's just 0 and 180 degrees for this one. 360 does not count, it's outside our range. Inverse tan of 4 then. Make sure you're in degrees. 75.96. 75.96, and then cast diagrams, what a lot of people usually use, so I'll just use that. We're positive, so I can do 180 plus 75.96, which gives me 255.96. So x equals 0 and 180, and x equals 75.96 and 255.96. Or you might prefer 76 and 256, and that would probably be fine as well. Okay, we're done there. SQA Higher Maths 2023, paper 2, question 7. Solve sin x plus 2 equals 3 cos 2x. So it's a trig equation. I'm going to have to expand cos 2x, and I'm going to have to use the sine one. So I'm going to rewrite that as sin x plus 2 equals 3 times. If you go back to the start of your exam paper, cos 2x is 1 minus 2 sine squared x. So then we can start tidying that up. Sin x plus 2 equals 3 minus 6 sine squared x. I'm going to take everything over to the right because it's going to be a quadratic sine squared sine and a number. So taking the 6 across, I get 6 sine squared x. I've got plus sine x. And we've got 2, then take away 3 is minus 1. And that equals 0. So we want to find how to factorise this, and it will be factorisable. So I'm going to show you a way. I'm just going to kind of write m squared, 6m squared plus m minus 1, so you can see this. That's basically the same quadratic. Now, to factorise that, if I times the 6 and 1 together, I get 6. So I'm looking for numbers that times together to make 6, but add together to make the 1 in the middle. So that could be 6 and 1 or 3 and 2. Well, it's clearly 3 and 2. And how is it 3 and 2? Well, it's plus 3 minus 2 equals 1, and 3 times minus 2 is minus 1. So we can now split the middle term. So we've got 6m squared plus m minus 1 becomes 6m squared plus 3m minus 2m minus 1. And then we just factorise each side. So 6m squared plus 3m. 3m is a common factor. You get 2m plus 1. And you've still got 2m plus 1 on this side because you need it to be the same. And it's just going to be minus 1 then, times 2m plus 1. So factorised, that is going to become 2m plus 1 and 3m minus 1. So then taking this and making it our sign, that becomes double brackets, m is just your sine x. So we've got 2 sine x plus 1, and we've got 3 sine x minus 1. And you might have got to that factorisation just by looking. Great if you can. So that means 2 sine x plus, and that equals 0, remember. 1 equals 0, or 3 sine x minus 1 equals 0. So the left-hand side, sine x is equal to 1 becomes minus 1 over 2. Minus 1 over 2, and the other one, sine x, is equal to 1/3. So we need to do the inverse sine of just a half in a calculator. If you don't know it, it's a calculator paper after all. The inverse sine of a half is 30 degrees. That's the exact value. But we need a cast diagram to pick the correct values because our sign was negative. So when the sign is negative, it's in these two quadrants, which is 180 plus and 360 minus. So our first two answers for the left-hand side, are x equal 180 plus 30, which is 210, and 360 minus 30, which is 330 degrees. Now looking at our sine x equals 1/3, we do the inverse sine of 1/3 on our calculator. And if we do that, we get an answer of 19.47. And again, our cast diagram for that side, this time the sign was positive, so it's just 180 minus it. So our other answers are 19.47, and we do 180 minus 19.47 in our calculator, and that gives us our final answer of 160.53. Or you'd be fine with 19.5 and 160.5. SQA Higher Maths 2015, Paper 2, Question 9 for the addition and double angle formula. The winds of a turbine are turning at a steady rate. The height h of the tip of one of the blades above the ground at any time t seconds is given by the formula. Express 36 sine 1.5t minus 15 cos 1.5t in the form k sine 1.5t minus a. So we can write 36 sine 1.5t minus 15 cos of 1.5t equals, well, k sine 15t minus a. K sine 1.5t, sorry, minus a. So expanding the right-hand side, that's going to equal k sine 1.5t cos a minus k sine a cos 1.5t. If we look at what's in front of sine 1.5t here, we get 36. So 36 equals what's in front of sine 1.5t on this side, k cos a. And similarly, looking at what's in front of cos 1.5t on this side is minus 15. And in front of cos 1.5t on this side is minus k sine a. To rewrite that more nicely then, I can say that k cos a equals 36 and k sine a equals 15. And now we're ready to get our k. Because sine squared plus cos squared equals 1, that means our k squared will be 36 squared plus 15 squared. So in other words, k is equal to the square root of 36 squared plus 15 squared, a bit like Pythagoras. So that is the square root of 1521. Use your calculator to verify that. And the square root of 1521 is 39. So we know that k is equal to 39. And also we can work out our a, because sine divided by cos is tan. So since tan a is sine a over cos a, I can write tan a is equal to 15 over 36. So I can find the inverse tan of 15 over 36. Inverse tan of 15 over 36, making sure my calculator is in radians, is 0.395. And now I just need to check which quadrant our angle is in. So drawing a cast diagram would help with this. Now remember, we're going back and looking at what cos and sine were. Well, we're both positive. So cos was positive, so that's A and C. And sine is positive, so that's A and C. So I'm in the first quadrant, so that means that A equals 0.395. And therefore, to answer our question, we get 39 sine 1.5t minus 0.395. And we're done there. So to follow on this question, it then says, and hence find the two values which tip of blade is at a height of 100 metres above the ground during the first turn. So we've just expressed this in this form, but then you've got plus 65 on the end. So we can just write that again, plus 65, and that's going to equal 100. So I'll go ahead and do that. So that means, I'll just call this part 2, our h equals 39 sine 1.5t minus 0.395 plus 65, and that's going to equal 100. So we've just got an equation to solve now. That means I can take the 39 with 65 across, so we get 39 sine 1.5t minus 0.395 equals 35. So dividing through by 39, we get sine 1.5t minus 0.395 equals 35 over 39. So at this point, I can find the inverse sine of 35 over 39 using a calculator and get a value. The inverse sine of 35 over 39 is 1.114. And looking at our cast diagram, sine is positive, so it's in the first and second quadrants, so that's pi minus the answer. So we can also do pi minus 1.114 to get a second solution, and that is going to be 2.03. So that means we can say that the whole of this equals that, and the whole of this equals that, and solve for t. So 1.5t minus 0.395 equals 1.114, and 1.5t minus 0.395 equals 2.03. So solving the first equation, 1.5t, adding 0.395, we get 1.509. And therefore t is 1.509 divided by 1.5, 1.006. There's our first solution. And our second solution, 1.5t equals 2.03 plus 0.395, which is 2.425. And therefore t dividing through by 1.5, 1.617. Just put my units in here, so that's seconds and that's seconds. And we're done there. So related functions, SQA Higher Maths 2015, paper 1, question 4. The diagram shows the graph of a function y equals p cos qx plus r. So it's a trig graph. Write down the values of p, q, and r. Okay, so we need to start off with what this function is. The normal cos graph, if you remember, goes between 1 and -1, like so, and it goes up to 2 pi. So the number in front is called the amplitude, then the period of it, the frequency, and then how far it's moved up or down. So immediately we can see that if we look at the q first, we've got 1 up to pi over 2, which means if I was to keep drawing that, I would have 4 up to 2 pi, because pi over 2 is 90 anyway. So I can immediately write down that q equals 4, because I should have 4 of them up to 2 pi. Okay, to get our amplitude, if we just work out the difference between the maximum and minimum, I've got 4 and -2 is 6. So to get p, I can just do 4 to -2 is 6. Half of that is 3, so I get 3. P is 3. And then for r, well, now I've got p, it's easy. If it was just 3 cos x, it would go up to 3, but it starts at 4, so I've added 1. So r is just equal to 1. And we're done there. We'll write down the values of p, q, and r. In other words, the function is 3 cos 4x plus 1. SQA Higher Maths 2018, paper 2, question 8. The wave function, part A, expressed 2 cos x minus sin x in the form k cos x minus a. Okay, quite standard question here. If we're to express it as k cos x minus a, I expand k cos x minus a and then equate both sides. So for part A, I can write 2 cos x minus sin x equals, start of exam paper, k cos x minus a is k cos x cos a. And then it becomes plus k sin x sin a. Because k's times everything. You could have like k bracket that, then expand the bracket. It's quite easy to do it that way. So looking at what is in front of our cos x, on this side in front of cos x and attached to it is k cos a, and on this side it's just 2. So I can immediately write k cos a equals 2. And similarly, looking at our other sin x, that's attached to k sin a, and this sin x is attached to a minus, so a -1. So I can immediately write k sin a equals -1. And now we need to just get our k's and get our a's. So to get our k's, because sin squared plus cos squared equals 1, you can just write straight away that k is the square root of 2 squared plus -1 squared. Just like Pythagoras. That's the square root of 2 squared is 4 plus 1 squared is 1. That's root 5. So our k is root 5, and that's a simplified third. We'll now work on getting our a. Because sine divided by cos is tan, I'll show you that here. Tan a is sine a over cos a. Tan a equals sine a is -1, or k sine a is -1, and k cos a is 2. But the k's cancel when you divide them, so you just get -1/2. So I need to do the inverse tan of a half. So the inverse tan of a half is 26.6 degrees. And then using our cast diagram to see which quadrant our angle is in. Now remember with this one, although it's tan A is negative, so you're tempted just to say T, S and C, it's to do with what sine and cos were. So sine was negative and cos was positive, so we tick for cos and sine. So when cos is positive, it's these two, and when sine is negative, it is these two, so it's in the fourth quadrant.
So that means that our A degrees is equal to 360 minus 26.6. So A is equal to 333.4 degrees. And now we just write our answer as k cos x minus a. So our answer is root 5 cos x minus 333.4 degrees. And we're done there for part A. Part B hence allows us to find the maximum and minimum value of 6 cos x minus 3 sin x, and then find the value for which it occurs between 0 and 360. Well, if you look at this one here, that times 3 gives you this one here. So if I just times my answer by 3 to part B, I can find the max and minimum values. Well, just the minimum. Part B, since it is 3 lots of it, I can say we've got 6 cos x minus 3 sin x degrees is equal to simply 3 times the answer we just got, which is root 5 cos x minus 333.4 degrees, because it's a multiple. Okay, minimum value of this, well, let's look at a cos graph in general. A normal cos graph goes between 1 and minus 1. This is the amplitude, so this one goes between 3 root 5 and minus 3 root 5. So straight away we can say that our minimum value is minus 3 root 5. So there's our first thing, and then we have to work out where it occurs. So where does the minimum value normally occur? Well, usually it goes 90, 180, 270, 360. But this here, x minus 333.4, means it's been shifted to the right by 333.4. Now, if I shift from 180 to the right, it will take me outward for 360. So I need to find the next value. So you could just go up and then take away 360. Or if you imagine the cos graph continuing behind me, that would be minus 180. So I can just do that shifted to the right. I would get 333.4 minus 180. If I do that sum, I get 153.4. So it occurs at 153.4 degrees, and we're done there.
SQA Higher Maths 2025, paper 2, question 12. Solve 3 sin 2x plus 4 cos x equals 0. So 3 sin 2x, that's just 2 sin x cos x from the start of the exam paper, plus 4 cos x equals 0, and it's just between 0 and 360. So 6 sin x cos x plus 4 cos x equals 0. Common factor then, 2 cos x, 2 times 3 sin x, and then 2 twos is 4, equals 0. So we get 2 cos x equals 0 and 3 sin x plus 2 equals 0. So that gives me cos x equals 0 on this side and sin x equals negative 2/3. And we're working in degrees here. So cos x equals 0. If you're not sure, by the way, you have got a calculator. Inverse cos of 0 is 90. So we get x equals 90 here, and then it happens again at 270. So there's our first two answers. And then for this one, I'll do the inverse sine of 2/3, never in the negative. Shift sine 2/3 is 41.8. Cast diagram. Sine was negative, so we want to pick T and C. So our x for the sine one is 180 plus 41.8 and 360 minus 41.8. Two answers, and you can use a calculator to work them out. So let's just do that. 180 plus 41.8 is 221.8, and 360 minus 41.8 is 318.2. So there's our two answers, and we're done there. We've got all four answers. You can write them out in a line if you want, just to be neat. 90, 270, 221.8, and 318.2 degrees, all degrees, and we're done there.
2022 Higher Maths, Paper 1, Question 4. Y equals the square root of x cubed minus 2x to the power minus 1, where x is greater than 0. We have to differentiate this expression, so let's get ahead and do that. So our first step, or our first mark, is to rewrite the square root of x cubed is x to the 3/2. And we've still got minus 2x to the minus 1. If we've written that, we get a mark there for this x to the power 3/2. We now need to differentiate our terms. So our first mark is for differentiating our first term, which is 3 over 2. X, take away 1 from 3/2, and that's 1/2. There's a mark there. And then differentiating our second term, minus times a minus is a plus, so it's plus 2x to the power of minus 2, taking away 1. So our final mark is 1 here and 1 for this term here. We do not have to go any further than that in this question. So if you did go further, that's fine, but you don't have to.
SQA Higher Maths 2023 Paper 1 Question 1. Y equals x to the 5/3 minus 10 over x to the 4. So we need to get it ready to differentiate first to find the y by dx. So y equals x to the 5/3 minus 10 x to the minus 4. And then I can do the y by dx. Take a power to the front. Take away 1, so that is 2/3. And then take the power to the front in times, but minus times a minus is a plus, so plus 40 x to the minus 5. You probably don't need to go any further, but just for the sake of completeness, that would give you 5/3 x to the 2/3 plus 40 over x to the 5, and we're done there. SQA Higher Maths 2017 Paper 1 Question 8 on differentiating a polynomial. Calculate the rate of change of d of t is equal to 1 over 2t. So we need to get it ready to differentiate. Always need to do that. So d of t is equal to 1 over 2t to the minus 1. Do not be tempted to move this 2. That's just a half still. Separate it out. It's just the t that's moving. Once we do that, d dash t, take the minus 1 down, so we get minus a half t. Take away 1 from the power, we get minus 2. And we have to work it out when t is 5. So d slash 5 is equal to minus a half times 5 to the minus 2. Or minus 1 over 2 times 5 squared. Minus 1 over 2 times 5 squared is 50. So minus a 50th. Just a note, remember, rate of change means differentiate. Okay, differentiating a trig function. SQA Higher Maths 2018 Paper 1 Question 3. H of x is 3 cos 2x, find h dash pi over 6. So if h of x is 3 cos 2x, then h, straight away you can just do h dash x is equal to minus sine 2x, well, minus 3 sine 2x, but then we need to times by 2 because we need to differentiate the 2x part as well. So that's minus 6 sine 2x. This is a paper 1 question, so it's an exact value question. So h dash pi over 6 is equal to minus 6 times sine 2 pi over 6. Subbing it in. That equals minus 6 times the sine of pi over 3. Or if you prefer to work in exact values in degrees, that would be 60. So that equals minus 6, the sine of 60, root 3 over 2. 6 divided by 2 is 3, so it's minus 3 root 3. And we're done there.
1 question 12 was, given f of x is 4 sine 3x minus pi over 3, evaluate f dash pi over 6, or f dash, differentiate your function at pi over 6. So, f dash x, we can check the front of the exam paper to realise that sine becomes cos when you differentiate it. So you should first of all start by writing 4 cos 3x minus pi over 3. And just for doing that part without actually finishing the differentiation, which I'm going to do in a moment, gets you your first mark. For your second mark, you have to then realise that this is the chain rule. So you've got an inner function of 3x minus pi over 3. So you need to differentiate that and times the whole thing by that. So in other words, if I differentiate this part, that's the constant, so that's nothing. Differentiate 3x is 3. So I need to times by 3. So we get a second mark for realising that and writing down it. We're going to times by 3. And then our final mark, of course, is evaluating it. So I need to tidy it up and then substitute pi over 6 in. So f dash x equals 12 cos 3x minus pi over 3. So f dash of pi over 6. And this is an exact value, remember, because we are non-calculator. But I'll substitute it in first. 12 cos 3 pi over 6 minus pi over 3. We need to tidy that up. So that's 12 cos 3 pi over 6 minus 2 pi over 6, which is 12 cos 3 minus 2 is 1, so it's just pi over 6. Pi over 6, if you prefer to think in degrees, is 180 divided by 6, which is 30 degrees. So it's the pi cos of 30. If you're not sure of what that is, let's draw an exact value triangle. If this was 60 degrees, that would be 30 degrees up here. This would be 2, this would be 1. 2 squared is 4, minus 1 squared is 1, so that gives you 3. So we get the root 3. And we're looking at the cos, so it's opposite adjacent over hypotenuse, root 3 over 2. So you get 12 times the cos times root 3 over 2. 12 divided by 2 is 6, so you get 6 with the root 3 as your final answer. And for all of that extra work, it's 1 extra mark. A bit stingy of the SQA there. So there's our final mark at this point here.
SQA Higher Maths 2024, paper 1, question 3. Y is 5x squared plus 3 to the 7, find dy by dx. So this is the chain rule. So dy by dx equals, I'll take the 7 down, leave the function alone, 5x squared plus 3, and take 1 away for power, that's 6. And then I need to times by the bracket differentiated. So 5x squared becomes 10x. 3 is nothing. So then that just equals 7 times 10 is 70x. 5x squared plus 3 to the power of 6. And we're done there. Okay, the chain rule, SQA Higher Maths 2019, paper 1, question 6. Given that y equals 1 over 1 minus 3x to the half, and x is not a third, find dy by dx. Let's get it ready to differentiate. So y equals 1 minus 3x to the minus 5. So dy by dx minus 5 in the front, 1 minus 3x, take away 1 from the power, so that's minus 6, and then times by whatever's in the bracket differentiated, which is minus 3. So tidying that up, we get minus 5 times minus 3 is 15, 1 minus 3x to the minus 6, and we're done there. SQA Higher Maths 2024, paper 1, question 12. A function f is given by f of x is 12 cube root of x is greater than 0, and it says when x equals a, the rate of change of f with respect to x is 1. Rate of change differentiation. Find the value of a. So let's differentiate it. So let's differentiate it to find the rate of change. So I'm going to need f of x in a differentiable form. So I'm going to say 12x to the cube root of x. Cube root is a third. So that means I've got a third times 12x. Take away 1 for the power, minus 2 thirds. A third of 12 is 4, so I get 4x to the minus 2 thirds when we differentiate. And it says when f of a, when x equals a, the rate of change with respect to x is 1. So when x equals a, so f dash a, f a minus 2 thirds equals 1. So we need to solve this equation. So there's lots of ways you could do this, but I'm going to actually just put it back into 4 over a to the 2 thirds equals 1. So that means that a to the 2 thirds equals 4. So what is a to the 2 thirds? That's the cube root of a squared equals 4. So if I just cube both sides, That'll give me a squared, and 4 fours is 16 times 4 is 64. And the square root of 64 is 8, and x is greater than 0, so it is just 8. And we're done there. SQA Higher Maths 2023, paper 2, question 5. A function is defined as f of x is 3 minus 2x to the 4. Calculate the rate of change of f when x equals 4. So again, a power word, rate of change means differentiation, and then just sum in x equals 4. So f dash x, well, it's the chain rule, so I take 4 down to the front, times by 3 minus 2x, take away 1 for the power, which is 3, but then I need to differentiate then a function, which is minus 2, so I'm timesing the whole thing by minus 2. So f dash x is minus 8, 3 minus 2x cubed, because of the chain rule. Substituting in 4, f dash 4 is minus 8, 3 minus 2 times 4 cubed, that's minus 8, 3 minus 8 cubed, which is minus 8 times minus 5 cubed. Minus 5 cubed is minus 125. 8 times 125. 8 times 125 is 1000. Minus times a minus is a plus. So there we are. Increasing and decreasing functions, SQA Higher Maths 2018, paper 2, question 3. A function is defined as a set of real numbers given by f of x is x cubed minus 7x minus 6. Determine whether f is increasing or decreasing when x equals to 2. So we need to work out the gradient of the tangent at x equals to 2. So f dash x is equal to 3x squared minus 7. At x equal to 2, f dash of 2 in other words, we get 3 times 2 squared minus 7. That's 3 times 4 is 12, take away 7 equals 5. And then we need to write a little statement. Since f dash of 2 is greater than 0, the function is increasing at x equal to 2. And we're done there. The range of values for which the function f of it, SQA Higher Maths 2023, paper 2, question 10. Determine the range of values for which the function f of x is 2x cubed plus 9x squared minus 24x plus 6 is strictly decreasing. There's actually 2 ways to do this. Both involve stationary points. If you get the stationary points, you can then examine the graph to see where the derivative is negative, or you can just examine the nature of the stationary points. So let's just look at the stationary points first. Stationary points occur when f dash x is 0. So f dash x gives me 6 2's is f dash x, 3 2's is 6, 6x squared, 2 9's is 18, plus 9 18x, and minus 24. And I'm going to look at that equal to 0 for our stationary points. 6 is a common factor, so I get x squared plus 3x minus 4 equals 0. So double bracket that up. X and x. 4 and 1 make 3, plus 4 minus 1 makes 3. So that implies our stationary points occur when x equals 1 or x equals minus 4. So then there's 2 ways to go now. I'll give you both options. I'll use the nature table. If you're using a nature table, you'll go along to minus 4, along, and then along to 1, and then along. And then you're just going to examine the derivative. So looking at our derivative, a number before minus 4, let's try minus 5. Minus 5 minus 1 is minus 6. And minus 5 plus 4 is minus 1. A minus times a minus is a plus. So it's positive there. It's 0 here. Between these two numbers, let's just try 0 then. Minus 1 times 4 is minus. It's negative there, so it's still negative there. It's 0 there. And then a positive number like 2. 2 minus 1 is 1. 2 plus 4 is 6. Positive times a positive is a positive. So it's increasing before minus 4. And then it's a turning point. And then it's decreasing. Still decreasing, of course. And then it's increasing. So we could say strictly decreasing when minus 4 is less than x is less than 1.
in between those two numbers. Or if you, and that works as well because the function is continuous. If it was discontinuous, you'd be a little bit knackered, but we know it's continuous because it is. Now, if we move on to the other way, we could look at just the graph. So graph of the derivative, we know the derivative is quadratic with stationary points at -1 and 4. So 1 and 4, so 1 and -4, sorry. So 1 and -4, and it's a normal there. So same idea. That's the graph of the derivative. That's the graph of f dash x. And that's negative below the x-axis, which is down here. So it's between -1 and 4. So again, you would stay the same answer. -4 is less than x is less than 1. Either of those options will give you your marks probably.
SQA Higher Maths 2025, Paper 1, Question 1. A curve has equation y equals x cubed minus 2x squared plus 5. Find the equation of the tangent to this curve out at point equals x equals 2. Equation of the tangent means I need to differentiate. So I do the y by the x, and that tells me the gradient. 3x squared, 2 2's is 4, so 4x, and the 5 disappears, and I want to do that at x equal 2. So at x equal 2, the y by the x is 3 times 2 squared minus 4 times 2. 3 times 2 squared is 4, so that's 12. 4 2's is 8, so I get 4. And that's my gradient. Now I need a point. I've got x equals 2, but I need to find the y. So at x equal 2, we've got y equals 2 cubed minus 2 times 2 squared plus 5. That's 8. 2 2's is 4 times 2 is also 8. Plus 5, which is just 5. So I've now got my gradient, 4, and my point, which is 2, 5. So I can sum into y minus b as mx minus a. Y minus 5 equals 4x minus 2. Y minus 5, 4x minus 8. So y equals 4x minus 8 add 5 is minus 3. And we're done there. SQA Higher Maths 2018, Paper 1, Question 7 for the equation of a tangent. You've got this curve shown in the diagram. Write down the coordinates of P, the point where the curve crosses the y-axis. So for part A, cuts the y-axis when x equals 0. So subbing 0 in, that's really easy. 0 minus 0 plus 0 plus 5. When x is 0, y is 5, so it's 0, 5. Part B, determine the equation of a tangent to the curve at P. The equation of a tangent, I can find the gradient by differentiation. So dy by dx is equal to 3x squared minus 6x plus 2. And at the point P already we know is x equal to 0, y equals 5. So when x equals 0, the y by dx equals 3 times 0 squared minus 6 times 0 plus 2. 0, 0 plus 2 equals 2. So our gradient equals 2, and our point P, remember, is equal to 0, 5. So y equals mx plus c is the easiest one to use here. Y equals 2x plus 5. Or you could use y minus b equals mx minus a and still get 2x plus 5. Question C, find the coordinates of Q, the point where the tangent meets the curve again. So you're just going to solve simultaneous equations here. X cubed minus 3x squared plus 2x plus 5 was our curve. It's equaling 2x plus 5 at points of intersection. So we can solve that quite easily. If these cancel each other out, if we take it over, minus 2x minus 5, they disappear. So that just leaves me with x cubed minus 3x squared equals 0. Common factor of x squared, so you get x minus 3. So that means that x squared equals 0, so x equals 0, or x minus 3 is 0, so x equals 3. Well, we already know 0 is one of our points, so the second point of intersection is that x equal to 3. So when x equals 3, y equals 2x plus 5. So that is 2 times 3 is 6 plus 5, which is 11. The second point is 3, 11, and we're done there. SQA Higher Maths 2023, Paper 1, Question 8. A function is defined as a set of real numbers by x cubed minus 3x squared minus 9x plus 5. Find the coordinates of the stationary points of f and determine their nature. Stationary points means derivative equal to 0. So we can write stationary points occur when f dash x equals 0. So f dash x is equal to 3x squared. 2 times 3 is 6, so 6x minus 9, and then the 5 disappears. So we're saying 3x squared plus 6x minus 9 equals 0. 3 is a common factor, so we get x squared plus 2x minus 3 equals 0. It's keeping our common factor, a standard one to factorise. We've got x and x. It has to be 3 and 1. And plus 3 minus 1 is 2. So that implies x minus 1 is 0, so x equals 1. Or x plus 3 is 0, so x equals minus 3. So we've now got our x part of the coordinate. We might as well try and find our y part. So when x equals 1, y equals, substitute into the original, x cubed plus 3x squared minus 9x plus 5. 1 cubed plus 3 times 1 squared minus 9 times 1 plus 5. So that gives me y equals 1 plus 3 minus 9 plus 5. Y equals 1 plus 3 is 4. 4 plus 5 is 9. Minus 9 is 0. So our first coordinate is 1, 0. When x equals minus 3, we can do the same thing. So y would be minus 3 cubed plus 3 times minus 3 squared minus 9 times minus 3 plus 5. So keeping your wits about, because it isn't on calculator, 3 cubed is 27, so you get minus 27. 3 squared is 9 times 3 is plus 27. 9 times 3 is 27, but it's plus because of a minus times a minus. And then you've got plus 5. Minus 27 plus 27 is obviously 0. So then you've got 27 plus 5, 32. So your second stationary point is minus 3, 32. So there's my two stationary points. Now we need to determine their nature by using a nature table. So a nature table is like this. We're going to go along to our first point. This is our x, so minus 3. And then along. And then we're going to examine the other stationary point. So I'm going to go along to 1. And then along. I always keep it separate in case there's a point of a discontinuous point. I don't want to lose marks for it in this case, but just in case. So then we're just looking at our derivative, f dash x. So picking numbers, we know that at minus 3 it's 0, and at 1 it is 0. So we need a number less than minus 3. Now, it's always best just to read a derivative to examine it already factorised. So just pick a number less than minus 3. Let's just pick minus 4. Minus 4 minus 1 is negative. Minus 4 plus 3 is negative. A negative times a negative is a positive. So I know it's positive before minus 3. So I can just write that. And after minus 3 but before 1, let's just put 0 in. That gives you negative. And that gives you positive. Negative times a positive is a negative. So we know that it's negative here. And therefore, after minus 3 but before 1, it's still negative. After 1 though, just pick 2. 2 minus 1 is positive. 2 plus 3 is positive. Positive times a positive is a positive. So we get a positive again. So our shape, it goes up, along and down. So max, down, along and up. So it's a min. So we need to state that. So minus 332 is a maximum turning point. And 1, 0 was it? 1, 0 is a minimum turning point. And we're done there. Stationary points under nature, SQA Higher Maths 2019, paper 1, question 1. Find the x coordinates of the stationary points on the curve with equation y equals a half x to the 4 minus 2x cubed plus 6. stationary points occur when the y by dx equals 0. So we can find the y by dx. 4 times a half, well, that's 2x cubed. Take away 1 from the power. 3 times 2 is 6, so minus 6x squared, and then 6 goes to nothing. In our little statement, stationary points occur when the y by dx equals 0. We've got 2x cubed minus 6x squared equals 0. Common factor of 2x squared to get x minus 3. And that means that x equals 0 because 2x squared equals 0, or x equals 3. And there we are. Simple as that. Graph of the derived function. SQA Higher Maths 2019, Paper 2, Question 5. The diagram below shows the graph of a cubic with stationary points at minus 2 and 4 as shown on the diagram of your answer book. Sketch the graph of g-x, the derivative. Okay, so let's just draw a picture here. Y and x. Now, we should first of all look at this. It's telling us it's a cubic. A cubic differentiates to a quadratic. So we're expecting a quadratic either going down the way or up the way. And we really just need to identify the roots. Well, the roots happen when the turning points, because the derivative equals 0. So it's just, I need to know that stationary points occur when the y by the x is 0, which means that these are my roots. So I get a root at minus 2 and a root up at 4. So that means that if we examine before minus 2, it's going up the way. It's then dropping down the way, and the derivative will be going back up the way. So it's above the x-axis before minus 2. It's below, in between the roots, and it's above again after 4. So that's how I like to think of this. So I know I'm starting high. I'm dropping below between the numbers, and then I'm going high again. So my curve must come down like so. Obviously, I can't quite get the turning point. I know the turning point happens at 1 in the middle of the roots, but I don't know exactly what it would be on the y-axis, so I don't need to work that out. And there we are. There's my graph of the derivative. The derived function. SQA Higher Maths 2019, Paper 2, Question 5. The diagram below shows the graph of a cubic with stationary points at minus 2 and 4 as shown on the diagram of your answer book. Sketch the graph of g-x, the derivative. Okay, so let's just draw a picture here. Y and x. Now, we should first of all look at this. It's telling us it's a cubic. A cubic differentiates to a quadratic. So we're expecting a quadratic either going down the way or up the way. And we really just need to identify the roots. Well, the roots happen when the turning points, because the derivative equals 0. So it's just, I need to know that stationary points occur when the y by the x is 0, which means that these are my roots. So I get a root at minus 2 and a root up at 4. So that means that if we examine before minus 2, it's going up the way. It's then dropping down the way, and the derivative will be going back up the way. So it's above the x-axis before minus 2. It's below, in between the roots, and it's above again after 4. So that's how I like to think of this. So I know I'm starting high. I'm dropping below between the numbers, and then I'm going high again. So my curve must come down like so. Obviously, I can't quite get the turning point. I know the turning point happens at 1 in the middle of the roots, but I don't know exactly what it would be on the y-axis, so I don't need to work that out. And there we are. There's my graph of the
SQA Higher Maths 2018, Paper 2, Question 9 on differentiation and optimization. A sector with a particular fixed radius x and the perimeter p of the sector is given by this. Find the minimum value of p. So stationary points occur when you differentiate and make it equal to 0. So starting with p of, that's a function of x, that's 2x plus 128 x to the minus 1. So p dash x is simply 2 minus 128x to the minus 2, or it's equal to 2 minus 128 over x squared. So stationary points when p dash x equals 0. So that gives me 2 minus 128 over x squared equals 0. So we need to solve that equation, so getting rid of a denominator. So we have got, imagine that's over 1. Common denominator is x squared. You get 2x squared on the top minus 128 equals 0. So then we can just say that that's like over 1, 0 times x squared 0, and this times 1. So we get 2x squared minus 128 equals 0. Simple to solve that one. We'll just say 2x squared is 128. And x squared then is half of that, which is 64. So x is the square root of 64. So x would equal 8 or minus 8, but x is greater than 0, so we can just disregard that one. So we've got x equal to 8. We now need to do a nature table to make sure that it's a max or a min. So looking at our nature table, we've got x, we're going along A8 and along, and then we're looking at p dash x. So a reminder of p dash x, it was 2 minus 128 over x squared. Now obviously you can't pick 0 because you divide by 0, so any other number, 1 maybe, and 10. If I put 1 into this, I get p of 1, p dash of 1 even, is equal to 2 minus 128. Well, that's clearly negative. That's 0, and then if I put p dash 10, that's 2 minus 128 over 100. Well, that's 2 minus 1.28, which is positive. So our shape is down, along, and up. And therefore, x equal to 8 is a min turning point. We have to find the minimum value of p. So remember, p of x was equal to 2x plus 128 over x. So at 8, that gives me 2 times 8 plus 128 over 8. That's 16 plus 1, and that gives me 4. 8 5s are 48, 6 is 48, which is 32. Well done there.
Determine the coordinates of the stationary points in the curve with equation a third x cubed minus x squared minus 3x plus 1, then the greatest and least values between that interval. Well, let's do part A first. Stationary points occur, you need to write this when dy by dx equals 0. So what's dy by dx? 3 times a third is 1, so it's just x squared minus 2x minus 3, and we're going to say that equals 0. So we should be able to solve that. Let's hope it factorizes. X and x, 3 and 1. And we've got minus 3 plus 1 is minus 2. So there we go. So x is minus 1 or x equals 3. Now read the question, determine the coordinates. So when x equals minus 1, y equals 1/3 minus 1 cubed minus minus 1 squared minus 3 times minus 1 plus 1. So minus 1 cubed is minus 1, so that's minus a third. Minus 1 squared is 1, times a minus is minus 1. Minus 3 times minus 1 is plus 3, and then I've got plus 1. So I've got 1 minus 1, 0. 3 minus a third is 8/3. But you can use a calculator anytime you want. So the coordinate is minus 1 8/3. So that's our first coordinate. And our second coordinate, when x equals 3, y equals a third times 3 cubed minus 3 squared minus 3 times 3, and then we've got plus 1. So 3 cubed divided by 3, 3 3s are 9, 3 is 27, divided by 3 is 9. 3 squared is also 9. 3 3s is 9, plus 1. 9 minus 9 is 0, minus 9 is minus 9, plus 1 is minus 8. The coordinate is 3 minus 8. And we've got both our coordinates. Notice it doesn't actually mention to find our nature, so there's no actual real need to do so. Part B. Determine the greatest and least values of y in the interval -1, x, and 6. -1 is less than x is less than 6. In the equation, a third x cubed minus x squared minus 3x plus 1. Now, with this is us testing limits here. Now, at the end, either the maximum occur at the end of these points or they occur in the middle, in which case you occur at a turning point. Now, one of the turning points is already -1, so we've already checked -1 is 8/3. So when x equals -1, we can already say that y is 8/3. We've already got a 3 for our turning point. When x is 3, y is -8. So now we just need to check 6 to see if that one is bigger or smaller. So when x equals 6, y is 1/3 times 6 cubed minus 6 squared minus 3 sixes plus 1. Hopefully you can kind of see that this is going to be a big number, because let's just get a calculator. 6 cubed, divide that by 3 is 72, minus 36, minus 18, plus 1. Now, since I've got a calculator out, I'm not going to be stupid, I'm going to actually use it. That is 19. So then we just say the answer. Now just answer a question. The greatest value is equal to the biggest of all the numbers. We've got 8/3 minus 8 and 19. 19, you could say at x equals 6. You don't need to. And the least value is the smallest number, which is -8. And that occurs at x equal 3. And we're done there. Okay, stationary points under nature, SQA Higher Maths 2017, paper 2, question 7. Find the x coordinate of the stationary point on the curve with equation y equals 6x minus 2 root x cubed. Then find the greatest and least values of y in interval 1 is less than or equal to x and less than or equal to 9. So part A, stationary points occur when the y by dx is 0. So we need to get it ready to differentiate. So with part A, I've got y equals 6x minus 2. I've got x cubed, so the cubed comes along for a ride, but it's a square root, so it's over 2. The y by dx then, 6 minus 2 times 3 over 2, x to the half, because I take away 1 from the power, and then we can say that stationary points occur when the y by dx equals 0. So making this equal to 0, we get 6. These 2's cancel, so minus 3. X to the half equals 0. So 3x to the half equals 6. X to the half equals 2. Remember, x to the half means the square root of x equals 2. So I'm looking for, if I square both sides, I get x equals 4. And we're done there. Part B, hence determine the greatest and least values of y. So at x equal to 1, y equals 6 times 1 minus 2 times the square root of 1 cubed. 6 times 1 is 6, minus 2 equals 4. At x equal to 9, the other one, y equals 6 times 9, minus 2 times the square root of 9 cubed. 6 times 9 is 54, minus the square root of 9 is 3, so 2 times 3 cubed. 54, 3 3's are 9 times 3 is 27, 27 times 2 is 54, that gives me a big 0 is the answer at the limits. So now I need to evaluate it at x equal to 4. So at x equal to 4, we've got y equals 6 times 4, minus 2 times the square root of 4 cubed. 24 minus 2 times the square root of 4 is 2, so 2 cubed. 24, 2 cubed is 8 times 2 is 16. 24 minus 16 is 8. So then we can just state our greatest and least values. The greatest value is 8 and the least value is clearly 0. So greatest value equals 8, least value equals 0. And we're done there. SQA Higher Maths 2024, paper 2, question 4. The diagram shows the graph of a quartic function. Wow. The maximum turning point occurs at -4 at 1, 3. The graph of y equals f of x has a point of inflection at x equals 2. Now there's a turning point that doesn't turn, keeps going down. And determine the coordinates of the maximum turning point of the graph of y equals f of x minus 4 plus 2. Well, the turning point to start with is -1, 3. So we're starting with -1, 3. Now this bit here, the bit that says x minus 4 means a shift to the right by 4. So I'm going to go right by 4. And then the bit at the end, plus 2, up by 2. So that becomes -1 shifts to the right, -1 add 4, that gives me 3. 3 goes up by 2, that gives me 5. 3, 5, job done. Part B. In the diagram in your answer book, sketch a graph of the derivative, y equals f dash x. So I've got a method for this, and this is my method that I use. I do this as if I'm doing a nature table, basically, and I'm going to say that's my derivative. And I'm going along to the turning points, because the turning points on the graph of the derivative turn into roots, because the 0 gradient. So the first turning point is -1. And then we go along and we get another turning point at 2. And then we go along. And then we just examine what happens before and after this turning point. So checking my graph. I'm going up the way, so that's positive. Then I'm going down, that's negative. And then I'm going down again, that's negative. So it's positive, negative, negative. So I can just write that. So the first one is positive, that's 0, negative, that's 0, and negative. So in terms of thinking about where I'm drawing this, I'm drawing that above the x-axis, on it, below it, on again, and then below. So then what you do is you get your diagram. Now I've not got one because I've not got an answer book yet, because I'm not a student. So I'll just draw it by hand. X and Y. You put your turning points on as your roots, -1. Let's just call that 2. And I'm thinking I'm above before -1, so I'll just put a wee mark, just to remind me. And then I'm below after -1. And then I stay below. And then I need to go back up here and then go down a low. So that must be a turning point that I just touch and hug. So we can just kind of think of this as we're going to go down, we need to go up at some point, and then we're going to go back down. So that looks like a decent graph, and we're done there. SQA Higher Maths 2025, paper 2, question 10. A hotel owner is designing signs shown with room numbers. There's a sign. Each sign is a rectangle, right angle above it. The length and breadth is 5x. And y, we've got 5x and y, and the shorter sides of a triangle are 3x plus 4x. And obviously it's a right angle, it shows that the perimeter is given by that. So let's have a look and work on this. It also tells us that the area of the sign is 150. So let's start off, we have something for our perimeter. Our perimeter is all the way around, so I need to go y plus 5x plus y plus 5x plus y plus, well, just 3x and 4x. So that equals 5, 6, 7, 8, 9, 10, 11, 12x plus 2y's. So I need to get rid of that y somehow. It says the area of the sign is 150. So area is 150. Well, what is the area? It's base times length, or base times height, 5xy, plus, now this is a right angle triangle, so it's just half the base times the height to get the area of that. Half the base would be 2x times 3x. I'll write that out, half the base times the height. So that's 5xy plus a half of 4 is 2 times 3 is 6. And x times x is x squared. But that equals, remember, 150. And my perimeter in the question doesn't have a y, so I make y the subject. So 5xy equals 150 minus 6x squared. So making y the subject, y is 150 minus 6x squared over 5x. So we can write our perimeter as 12x plus 2y is 12x plus 2 times 150 minus 6x squared over 5x. So what's that? 12x 150 divided by 5 is 30, times 2 is 60, but then there's an x on the bottom. So then our other one, 2 6s is 12, so that's minus 12 over 5, but then the x will be an x squared over x, so that's just x on the top. So working that bit out, 12x minus 12x over 5 plus 60 over x. Now it had a decimal answer, so I'll just work it as a decimal. 12 minus 12 over 5. That's 9.6. So our perimeter is 9.6x plus 60 over x as required. But if you couldn't do that, you should have just moved on and skipped it, because you can do part B. Each sign will be using a lightning strip placed around its perimeter. The hotel owner requires the perimeter of the sign to be as small as possible. Find the minimum value of P. Optimization, differentiation. So part B, minimize this then. So stationary points occur when P dash equals 0. So P dash, well, I'm going to have to get ready to differentiate first actually. So P equals 9.6x plus 60x to the minus 1. So P dash is going to be 9.6 minus 60x to the minus 2, and that's going to equal 0. So there's a few ways to solve this, but what I usually like to do is just say that that's minus 60 over x squared. And then just times both sides by x squared. So that gives me 9.6x squared here, minus 60x squared over x squared, so it's gone, equals 0x squared. And then I can solve that. 9.6x squared equals 60. So x squared is 60 over 9.6. So x is the square root of 60 over 9.6. And I'm pretty sure the question told you that x would be greater than 0. It has to be anyway. Does it say anything about it? It doesn't, but once we square root that, we can't have a negative x because you can't have a negative length. So that will just be a positive. Which is 2.5, because x cannot be minus 2.5. Okay, so it is 2.5, and then we have to minimize the perimeter, so we actually have to sub that back in. But before we do that, we need to do a nature table to check that it's a minimum. Along to 2.5 and along, P dash, just pick 2 and 3, say. So subbing in 2, we get 9.6 minus 60 over 2 2s is 4. Well, that's a negative number. That's 0. And when we sub in 3, you get 9.6 minus 60 over 3 3s is 9, which is a positive number. So that goes down, along and up, and therefore x equals 2.5 is a minimum, TP, so x equals 2.5 minimizes the perimeter. Our perimeter was 9.6x plus 60 over x. 9.6x plus 60 over x, so that's 9.6 times 2.5 plus 60 over 2.5. 9.6 times 2.5 plus 60 over 2.5 is 48. So our minimized perimeter is 48. And I'm pretty sure our units were centimetres or metres. Let's have a look. Centimetres, I think. And we're done there. SQA Higher Maths 2023, Paper 2, Question 14. The net of an open box is shown. The base is 3x by 2x with a height of h. Find the area of a net in terms of h and x. So for part 1, we've got 3x times 2x for this bit here. And then this will be 2x because it's just going to go up the side with that. So that's 2x. And obviously this is 2x as well. We've got 3x here. And then if you just imagine that over the top or around the front, this will also be 3x. So you've got 3, 4, 5, 6, 7, 8, 9, 10.
So it's plus h times 10x. So that gives you 6x squared plus 10hx. And it's only worth 1 mark, so there we are. Part 2, given the area is 7,200 centimetres squared, so the volume is given by this. Well, volume of a cuboid is area of the base times the height. Well, the base is this bit here, which we already know is 6x squared. So that's 6x squared h. But that's got h in it, so we need to get rid of that h. But we already know that 6x squared plus 10hx equals 7,200 from the question. So we can rearrange that to find h. So 10hx is 7,200 over 6x squared. So h is, so 10hx is 7,200 minus 6x squared. So h is 7,200 minus 6x squared all over 10x. So now our volume is just going to be 6x squared times the whole of that. I've not simplified that yet, because I'll just simplify at the end. So 7,200 minus 6x squared over 10x. So that means our volume equals, well, dividing through by 10 first, I think, we'll get 6x squared, 720 over x, minus 3/5 of x. So what I've done there, divided this by 10, so it's still over x. And then dividing this by 2, you get 3/5. X squared over x is just x. So now I can expand the bracket. 6 times 720 is actually 4320. Use a calculator, so you get 4320. X squared over x is just x. And then 6 times 3 is 18 over 5. We'll just leave it like that. Yep, minus 18 over 5. And we get x cubed. Part B, determine the value of x, which maximizes the volume of the box. So it's maximize, optimize. Let's go. So for part B, to maximize the box, we need to examine the stationary points. So stationary points occur when the derivative equals 0. So v dash, well, it's a function of x, I suppose, is equal to 4320. And that's going to be minus 18 times 3 over 5 x squared. So v dash x is 4320. 3 times 18, 3 tens are 30, 3 eighths is 24, so that's 54. So minus 54 over 5 x squared. And we're going to make that equal to 0. So we can say that 54 over 5x squared equals 4320, just like that, taking that over to the other side. So dividing, timesing by 5 and dividing by 54, I'll do that. So actually 54x squared equals 5 times 4320, which is 21600. So x squared is the square root of, divided by 54 is 400. So x is the square root of 400, which is equal to 20. Now just have a little note on this. It's actually equal to minus 20 as well, but you can't have a negative length, so it's only 20 the one we're picking. So it's just 20 we're looking at. Now we just need to check, is that a max or is that a min? So x along to 20 and along, examining the derivative to see if it's a max or a min. Okay, so we need to examine before and after 20. So let's try a number before 20. So let's try 19. 19 squared times 54 divided by 5. That number is smaller than this number, so that minus that is positive. So it's positive before 20. It's 0 at 20. Then if you try 21, the same idea. 21 squared times 54 divided by 5 is bigger than 4320. So 4320 minus that is negative. And therefore, we've just worked out
that x equals 20 is a maximum turning point. So the box is maximized by x equals 20. Is it centimeters? Yeah. Centimeter. How well done there?
Question carefully is really just an optimization question. Have a look, see if you can have a go at it, and then come back when you're done. Minimize the cost of production. Minimize optimization. That's your key power word for higher maths there. Let's try part A in any case. So there is our box and all the information in it, and I want the surface area. So I'm just going to start working on it and see if I can get the answer close to what we have got. So surface area, we've got 3x times h, and I can see I've got 1 of them, 2, 3, 4 of them. So first of all, I can write down I've got 4 times 3xh. I'll put a dot for times in so it's clear. And then I need to add on. Well, I've now got my top and my bottom. So my top is going to be 3x times 3x. So that's 9x squared. Times that by 2. So plus 9x squared. Plus another 9x squared, just to be clear. Or 18x squared straight away. But then you've also got a hole in the top, which is x squared by x squared. And I've got 2 of them, so take away 2x squared straight away. And then the bit that everybody can't always forgets, I almost forgot it, there's a surface inside this tube as well. So I need to work out what that surface is. Well, there's going to be 4 of them, and it's just going to be x times h. So plus 4xh. Tidying all that up a little bit, my area is 12xh plus 4xh. That's just my first and my last one. And then my x squared's 9, 18 minus 2 is 16x squared. Or my area is 16xh plus 16x squared. If you can get that far, you're getting a mark. But we're not finished there because our area in the question's not got any h in it. So we need to work out if we can eliminate that h somehow. Well, let's look at the information. The volume is 2000. Well, volume is length times breadth times height. So if I write that down and underneath, volume is length times breadth times height. Volume of the big box, which is 3x times 3x, which is 9x squared times h. So 9x squared h, but we need to remember to take away the whole, which is x by h. So that's just x squared h. So our volume, 8x squared h, but that equals 2000, it says. So I can now eliminate h from my area by rearranging this equation to make h the subject. So that means that h equals 2000 divided by 8x squared. A mark for getting h. Now we just need to substitute it into a. So our a is 16x times h, 2000 over 8x squared. And we've got still plus 16x squared. Using a calculator, 16 times 2000 divided by 8 is 4000. So we get 4000 on the top. And we've got cancellation to do. X on the top, so x squared becomes x. So we get x on the bottom. Plus 16x squared. Or writing it in exactly the same way we wanted, 16x squared plus 4000 over x, which is just exactly the same as what I've just already got. And there's your third and final mark. Part B said, to minimize the cost of production, the surface area A of the box should be as small as possible. Find the minimum value of A. Minimum value optimization. Let's jump straight in. So part B, I want to optimize the area. To differentiate a function, we need to get it ready. So let's start with our area. We've got 16x squared, but I'm going to have to take that 4000 x to the minus 1. So I can differentiate it. And you'll actually get a mark straight away there for getting it ready. We now differentiate it. So a dash or a dash x, 2 16s is 32x minus 4000 x to the minus 2. And that's me differentiated it for a mark as well. So 2 marks out of 6 so far. Now, if we fix that by making it equal to 0, because we're optimizing. So remember, stationary points occur when a dash x, I'll call it, equals 0. So we can say 32x minus 4,000, x to the minus 2 equals 0. For realizing we had to do that and find stationary points, we get another mark. And then we need to solve it. We'll get another mark in a moment for solving it, but I'll show you all the working you need for solving it. So we've got 32x equals 4,000 over x squared, we could say, x to the minus 2. So multiplying through by x squared, we get 32x cubed equals 4,000. Dividing through by 32, 125. So x is the cube root of 125. There's only one answer to that. It is 5. So we now know that x is 5 is our turning point. But we need to prove and show that that is a minimum. We don't know if it's a minimum or a maximum. So we need to do a table of signs. So let's do our table of signs just to show that. X going along 5 and we're going along. A dash x, so a number less than 5 but not 0 because 0 is undefined. Then if you picked 1, say, you would get 32 minus 4,000 over 1. That's a negative. So we've got negative 0. Hoping it after 5 is positive, but you can check. Just get yourself a calculator, pick a number close to 5. Let's pick 6, say. 32 times 6 is 192. 4,000 divided by 36 is 11. That minus 11 is positive, so we can say it's positive. So our shape is down, along, and up. Therefore, x equals 5 minimizes a. So to get a, remember, x equal to 5, we work out our area equals 16 times 5 squared plus 4,000 over 5, 1,200 for your final mark. A note on table of signs here. Technically, this is one of those ones where the function is discontinuous. In other words, at 0, because if you can't divide by 0, it breaks. You have to make sure that you have kind of shown that it's in the neighbourhood of 5. I always draw an arrow because the SQA take it to mean a number close to 5, a number close to 5 on either side. If you do that and don't actually say any numbers, you will be fine.
SQA Higher Maths 2024, Paper 1, Question 9. Express log A5 plus log A80 minus 2 log A10 in the form log AK, where K is a positive number or integer. So rules of logs, log base A of 5 and AA is plus, so 5 times AA. And then I'm dividing by something. Well, let's take that up to the top here. So let's do this one. That's log base A of 10 squared. So divide by 10 squared. So that gives me log base A. 5 8s is 40, so that's 400. 10 10s is 100. That's log base A of 4. I have to leave it in that form, so we're done there. SQA Higher Maths 2025, Paper 1, Question 4. 3 log base 3 2 plus log base 3 1 over 24. Rules of logs, log base 3 2, and then the 3 can come up as a power. Plus means times, so that's times 1/24 to get it as 1 log. So that's it as 1 log. Simplify that, that's 8 times a 24th. That's a third when you simplify the fraction. So what does that tell us? Well, 3 to the power of something is a third. 3 to the power of minus 1 is the same as a third because it's 1 over 3 to the 1. And therefore the answer to that question is minus 1. 3 to the power of minus 1 is a third. And we're done there. SQA Higher Maths 2023, Paper 1, Question 7. Part A, evaluate log 2 5 plus log 2 1 over 40. So part A, rules of logs again. But same base with a plus means I can times these two together. So that becomes log 2 5 times 1 over 40. So that is log base 2 of 5/40ths, which is log base 2 of an eighth, because you can divide by 5. So imagine it as 2 to the power of something as an eighth. Well, 2 to the power of 3 is 8, so 2 to the power minus 3 is an eighth, because it's 1 over 2 to the power of 3. So that means that 2 to the power minus 3 equals an eighth. So this means that the answer is minus 3. Part B. Given a is a member of the real numbers and that log 8a is negative, state the possible values of a. So we're saying that log base 8 of a is negative. So less than 0. We don't need to write the as. So log base 8 of a is less than 0. Let's just think about it logically for a minute. Let's imagine that we did 8 to the power 0, we would get 1. If we take a negative number then, we get 8 to the power of, let's say, negative 2. That's the same as 1 over 8 squared, which is a fraction. And if I take any negative number, 8 to the power of a massive negative number would be a fraction. So it's always going to be either as big as 1 or as small as almost 0. So that means that 0 is less than a is less than 1. We can see this on a graph, I suppose. If I draw a basic log graph, there is 1 there, and below the x-axis is when it's negative. So less than 1 is negative, but only up to 0. It never touches 0, so it's between 0 and 1. So that's another way you could have thought of it. SQA Higher Maths 2025, paper 1, question 8. Given that log a is 75 equals 2 log a3, find the value of a. So I need to bring the logs to the same side. Log a 75 minus log a3, and I'll just leave the 2 where it is. Rules of logs, I can combine that into 1 log as I divide. Simplify. 3/25 is 75. That means that the base to the power of 2 is equal to 25. So a is the square root of 25, but just the positive square root, just 5, because a is greater than 0. Tells you in the question, but also it has to be because you don't get a negative base log anyway. And we're done there. SQA Higher Maths 2022, paper 1, question 8. Solve log base 6x plus log base 6x plus 5 equals 2, where x is greater than 0. So a couple of different methods you could have used here, so I'll go through the alternatives for you. Let's call this one method 1. And the first method is to combine the two logs, the plus as one single log. So we could write that as log base 6 of x times x plus 5 equals 2. And there's your first mark there. Okay, moving to the second mark, we can write that as 6 squared equals x times x plus 5, or x times x plus 5 equals 6. So there's our second mark there. And then we can move on to try and solve that as a quadratic equation. So standard quadratic way, multiply out the brackets, we get x squared plus 5x, and that equals 36. So tidying that up, minus 36 equals 0. There's our third mark there for putting it in the proper quadratic form. And then our fourth mark, try to solve that. Double brackets, x and x, 9 and 4 times together to make 36, but take away make 5. So we've got plus 9 minus 4. So x equals 4 or x equals minus 9. But x has to be greater than 0 because it says so in the question.
So we disregard one of the answers. So since x is greater than 0, x equals 4 is the only valid answer. And there is our final mark right there. We have to have stated that x equals 4. We disregarded the -9 to get that final mark. Let's look at method 2. So method 2 starts the same way. We apply the same rule as before. So we write log base 6 of x bracket x plus 5 equals 2. And we get our first mark. The log base 6 of x plus 5 equals the log base 6 of 6 squares. Because remember, log base 6 of 6 is 1, so that is 2. And that would give us our second mark. And then we can cancel the logs from both sides to just write x plus 5 equals 6 squared, or x squared plus 5x equals 36. And it continues in the same way as the last method. Minus 36 is 0. There's our other mark. And then for our final mark, solving that equation, we get x and x, 9 and 4, plus 9 minus 4 equals 0. So x equals 4 or x equals -9. But since x is greater than 0, x equals 4 is the answer. And there's our final mark there for 4 marks.
SQA Higher Maths 2024, Paper 2, Question 11. The number of electric vehicles worldwide can be modelled by n equals 6.8 e to the kt, where n is the estimated number of vehicles in millions. Watch out for that word. T is the number of years since the end of 2020, and k is a constant. Use the model to estimate the number of vehicles worldwide at the end of 2020. So at the end of 2020, t equals 0. So you get n equals 6.8 times e to the 0, which is 1. So that's 6.8, but it's not 6.8. 6.8 million. You'll probably lose a mark if you miss that word because it's not 6.8. Part B. At the end of 2030 is estimated at 125 million electric vehicles worldwide. Determine the value k. So we want n is 125 million, 125 equals 6.8 e to the power of, and k, t. So t, 30, 20, 10 years, 10k. So that's a logarithmic equation. It's going to turn it. We're going to use logs because it's an exponential. So divide by 6.8. That equals e to the 10k. Take the natural log of both sides. ln, I'll write 1025 over 6.8 equals ln e to the 10k. 10k can come down to the front to get ln e, which is just 1, remember. And that is ln 125 over 6.8. And therefore, k is very simply ln 125 over 6.8, all divided by 10, which is a calculator job. Ln 125 over 6.8, all divided by 10, 0.2911, blah, blah, blah. I think 291 is fine, 0.291, and that's k. Have we answered the question? Yes. So we're done there. SQA Higher Maths 2025, Paper 2, Question 13. A radioactive substance has been collected, decays over time, and the mass is given by m equals 150 e to the minus 0.0054 t, where m is the mass and t is the years after the radioactive substance is collected. Find the initial mass of the substance. Initial means t equals 0, so m equals 150 e to the minus 0.0054 times 0. That's 150 e to the 0. Well, e to the 0 is just 1, so that's 150. It says it's in micrograms, I think. Yeah, so I'll just write micrograms to be on the safe side. And we're done there. Part B says, calculate the time taken for the mass of the substance to decay to 120. So m is 120. So I'll just write 120 equals 150 e to the minus 0.0054 t. That becomes a fraction. That stays your e there. I will simplify the fraction. So that's 12 over 15. And 3 goes into 12 4 times, and 3 goes into 15 5 times. Take the log of both sides now, because I've got my t in the power position. So ln 4/5 equals ln e to the minus 0.0054t. That means I can take my 0.0054t to the front. So ln 4/5 equals minus 0.0054t ln e. But ln e, remember, log e is 1. So that means I can work out my t is just ln of 4/5 all divided by minus 0.0054. Get your calculator. ln bracket, I've already got a bracket, 4 over 5 equals that. I'll press then divide minus 0.0054, 41.32 roughly. And it was in years. And we're done there. SQA Higher Maths 2023, paper 1, question 9. The diagram shows the graph of function f of x is log base 3x. X is greater than 0, of course. The inverse function does exist. In the diagram in your answer book, draw the graph of the inverse function minus 1. Well, let's examine the inverse function first. The inverse function of a log is an exponential. And essentially, the easiest way to draw it, imagine a dotted line here, y equals x. The coordinates just switch places, okay? So here is my normal y equals x. So 1, 0 becomes 0, 1. And 3, 1 becomes 1, 3. And it just gives you an exponential curve. And that would be 1, 3. So that's the inverse function of x. So now I just need to take away 1, which means just to move it down by 1. So 1 is going to go to 0. And 1, 3 is going to go to 1, 2. So I can just draw it now. There's 0. It's obviously going to drop below because that's where your asymptote is, essentially. So it's going to go along, up through 0, and start climbing. And we just put that point on that we noted, which was 1, 3. So it now becomes still 1, but 2. And we're done there. Solving logarithmic equations, SQA Higher Maths 2018, paper 1, question 11. Diagram shows log 3x. On the diagram in the answer book, sketch the curve of equation 1 minus log 3x, and then find the point of intersection between the curves, which will be solved with logarithmic equations. So 1 minus log 3x, the minus part here tells me to reflect in the x-axis, and then the 1 part, which I'll do in another colour here, tells me to then move up by 1. So first of all, reflecting in the x-axis, this point will stay where it is, but this point will jump down here, and that would be at the moment as in point 3 minus 1. But now I have to move up by 1, so this point is going to jump up by 1, so that becomes 1, 1. And you can see this point goes up to 3, 0. So I can just write the number 3 here. Getting rid of my intermediate working, which you could use a rubber if you were doing this by hand. And since it's reflected, it's going to go down and through here. So we can just draw that in, down here, through the way, and there we go. It's a reflection in the x-axis. Okay, part B, determine the exact value of the point of intersection. Simultaneous equations. So for part B, we've got y equals log 3x, but we've also got y equals 1 minus log 3x. So we can say that they are equal to each other and find x. So log 3x equals 1 minus log 3x. So taking the log 3x to the other side, you'll have log 3x plus log 3x. So 2 of them, 2 log 3x equals 1. I can take the 2 up as a power, so I get log 3x squared equals 1. Now I've got it in the form log of something equals a number, so 3 to the power of 1 equals x squared. 3 to the power of 1 equals x squared, and therefore I can find x. X equals 3 to the power of a half, or x equals the square root of 3. And we're done there. Notice it'll only be the positive part of this instead of the
negative part, because if x was negative, then you would have log of a negative number, which doesn't exist, so it's just a positive. I can take a note of that. Just positive value, as x has to be greater than 0. Relation from a straight line for logarithmic graphs. SQA Higher Maths 2019, paper 2, question 12. Two variables x and y are connected by the equation, and this is what you're looking for. Y equals ab to the x, a power. And we're looking at one of the axes is logged, but the other one is not. So it's only one log this time. But always start from your equation and get the logs coming out and see where you go. So I'll start with y equals ab to the x. We'll have to find the values of a and b. So let's start with y equals ab to the x. Just log both sides then. Our log base is 4. So looking on our graph, log base 4y equals log base 4 of ab to the x, which is a product. So I can separate that into a plus. So log base 4y equals log base 4 of b to the x. So like the x one first, like mx plus c, plus log base 4a. Taking the x to the front, we get log base 4y. That's a y and that's a log. Equals x times log base 4b plus log base 4a. Well, y equals mx plus c is our straight line, so let's put the x on the end so you can really see it. Log base 4y equals log base 4b times x plus log base 4a. So that's like y equals mx plus c. So we can see our gradient is equal to this number in front of x, and our c is equal to this. So we can say our gradient is equal to log 4b. So let's just check our graph to see if we can work out the gradient. We're given 2 points. So our gradient is equal to y2 minus y1 over x2 minus x1. So that's 8 minus minus 1 over 3 minus 0. That's 9 over 3, which is 3. So we know our gradient's 3. So log base 4b equals 3. Remember, that means that 4 to the power of 3 equals b. 4 cubed is b. 4 cubed is 64, and therefore b equals 64. Now let's try our c. From the work we've just done, our c is equal to log base 4 of a. C is where it cuts the y-axis. We know it cuts the y-axis at 0 minus 1, so c is minus 1. So we can just straight away say that minus 1 is equal to log base 4 of a, or if you prefer, log base 4a equals minus 1. Remember, that means 4 to the power of minus 1 equals a. You can just write that straight away. 4 to the minus 1 equals a. 4 to the power of minus 1 is 1 over 4 to the power of 1. So therefore, a equals 1/4. And we're done there.
SQA Higher Maths 2024, paper 2, question 6. Two variables x and y are connected by the equation y equals ax b. The graph of log 5y and log 5x are shown, and it's a straight line. So we've got log 5y by log 5x, and find a and b. Right, so I always usually start with the equation. Some people skip ahead, but I don't like to. So I'll start with that and I log both sides. The base is 5. Log base 5y equals log base 5 ax to the b. So now I can separate my log out on the right hand side to log base 5a plus log base 5x to the b. So that means log base 5y equals log base 5a plus b comes out the front, log base 5x. And put that in a kind of form of y equals mx plus c. You've got your log base 5y. I'll take the x bit first. So b times log base 5x plus log base 5a. So now just comparing your graph, your y-axis is log base 5y, so that's like your y, and your x-axis is log base 5x, so that's like your x. So that bit there is your gradient, mx, and that bit there is your c. So the gradient is b. So what's the gradient of this line? Well, I've got 2 points, 0, minus 2, and 410. So the gradient between 0, minus 2 and 410 is what we're going to do. So my gradient equals 10 minus minus 2, 4 minus 0, that's 12 over 4, that's 3. So that means that to answer the question, B equals 3. Now it says find C. Well, I already know where it cuts the y-axis, 0 minus 2. So that's it, C is minus 2. So if C is minus 2, that means that log 5a equals minus 2. So that means that 5 to the power of minus 2 equals a. That's 1 over 5 squared. 5 squared is 25, so a is 1/25. And we've got that, so we're done. SQA Higher Maths 2024 Paper 1 Question 10. Show that x minus 1 is a factor of that and then factorise it fully. We're just going to use synthetic division. 2, 3, minus 4, minus 3, 2. Putting 1 in, we get 2. 2 ones is 2, plus is 5. That's 5. 5 minus 4 is 1. That's 1. 1 minus 3 is minus 2. That's minus 2. And we get 0. We just say remainder 0. So x minus 1 is a factor. So now we have to factorise it fully. So for part B, we've now got x minus 1 times 2x cubed plus 5x squared plus x minus 2. So I need to find another factor. Now I've already got minus 1, so I could try 1, I could try 2 or minus 2. Or I could try any multiple of 2 times 2 is 4, any factor. Now I'm going to try, I've already done this to be fair with you, and I got it on 1. But you just keep trying numbers till it works. If you can't do it, I've got 2, 5, 1 and minus 2. And I know that minus 2 does work. So I get 2, 2 2s is 4, 5 minus 4 is 1, that's minus 2, plus 1 is minus 1, that's 2, that's 0. So again, remainder 0. That means that x minus plus 2 is a factor, because I put in minus 2. So then we can continue to factorise. X minus 1, x plus 2, and 2x squared plus x minus 1. So just check if that's factorisable. You can either see it or you can just check it in some other way. But I can see it as factorisable. 2x and x. 2 ones is 2, and then 1. So I want plus 2 minus 1. 2x squared plus 2x minus 1x is x. Minus 1 times 1 is 1 minus 1, so we're done there. SQA Higher Maths 2025, Paper 1, Question 7. Show that x plus 3 is a factor of this, and then hence otherwise solve. So you can sub in directly, or as most of you will do, you'll use this synthetic division. So you've got 5, 16, minus 1, minus 12, x plus 3, so I sub in minus 3. 5 minus 15, 16 minus 15 is 1. 1 times minus 3 is minus 3. Minus 3 minus 1 is minus 4. Minus 3 times minus 4 is 12, and we'll get 0. So since the remainder equals 0, that implies that x plus 3 is a factor. Well, the way you could say that is f of minus 3 is 0, so x plus 3 is a factor. Now we have to solve it, and it's the same equation. So for part B, we've already got x plus 3 as a factor, so I'll just write that again. And then we've got 5, 1 minus 4, 5x squared plus x minus 4 equals 0. So a little bit of hard factorising if it does factorise. Now if you're not sure if it factorises, check the discriminant. 1 squared is 1, 4 5s is 20, 20 times 4 is 60, and that's positive, isn't it? 4 5s is 20. If you're not sure if it factorises, check the discriminant. If the discriminant's a square number, it's factorisable. So 1 squared is 1, 4 5s is 20, 20 times 4 is 80, that's a minus minus. That gives you 81 for the discriminant. So that means it's definitely factorisable because 9 9s is 81. So a little quick check there. And if you've got a negative number for your discriminant, you know you've got all the solutions. So it must be 5x and x. I was going to write 5x twice there. And it can't be 5 times 4 is 20. That makes no sense because I'll never get back down to 1. So it must be 5 times 1, which is 5. The outside is 5. And then the inside must be 4, taking away 4. Take away 4 plus 1. So that means that x is equal to minus 3. 5x minus 4 is 0. 5x is 4, so x is 4/5. And finally, the other one, x equals -1, and we're done there. SQA Higher Maths 2024, Paper 2, Question 13. The diagram shows the graph of y equals f of x, which is a quartic function. How interesting. So, express f of x in the form kx plus a squared x plus bx plus c. Okay, so how you go about this is, those are roots, and roots can turn into factors. So, when x equals -1, the factor is x plus 1. Similarly, when x equals 3, our factor is x minus 3. But that's a turning point, and if a turning point is a root, that means that one's squared. And then when x equals 5, our factor is x minus 5. So we've straight away got f of x, and I'm going to write these in order. The order is written here, k, x plus a squared, x minus 3 squared, x plus b. So the next one I come to is minus 5n plus 1 or plus 1 and minus 5. It really doesn't matter, does it? What we got? Nah, it doesn't really matter at all. So I'll just put them in the order, x plus 1 and x minus 5. The order of it there appear as roots, minus 1 and 5. So we've still got a k in the way. But we've got a point, 0 minus 9. So you just sub that in. When x equals 0, y, which is f of x, is minus 9. So that means we've got minus 9 equals k, minus 3 squared, 0 minus 3, 1, and minus 5. 0 plus 1 is 0 minus 5. So minus 9 equals k times 9 times 1 times minus 5. So minus 9 equals 9 5s is 45, minus 45k. So k is minus 9 over minus 45. 9 is a common factor, so that's 1. 9 5s is 45, that's a fifth. Finally, answer the question. F of x is equal to 1/5 of x minus 3 whole squared, x plus 1, and x minus 5. And we're done there. SQA Higher Maths 2016, Paper 1, Question 15. Identify a polynomial from its roots. So the diagram below shows the graph of f of x, which is k, x minus a, x minus b squared. Find the values of a, b, and k. There's one of my roots there. And there's the other root there. That's a repeated root. And I know that because it's a turning point and a root. So that one is my b, and the other one is my a. So I can immediately say for part A, f of x equals k times x minus 4, x plus 5 squared. And then we can use the point 19 to work out our k. X equals 1, y equals 9, so we get 9 equals 1, k times 1 minus 4, 1 plus 5 all squared. So 9 equals k times minus 3. 1 plus 5 is 6. 6 6 is 36. So 9 equals minus 108k. So k is 9 over minus 108 minus 12. So we've got k as minus a 12. We've got a equals 4 and b was equal to minus 5. Remember, from our roots, 4 and minus 5. So we're done there. Part B says, for the function g of x equals f of x minus d, where d is positive, determine the range of values for d so that g of x has exactly one real root. Okay, let's have a look at this. If it's got one real root, it only crosses the x-axis at one point. So this is going to move down, so that makes it go, but it's still going up. So this turning point has to go underneath here. So that the only place it crosses is when it first initially drops down. Then it goes up, and it's going to turn before it hits there and go back down. Well, that length is 9, so d must be greater than 9, and it's as simple as that. So it's just really working that out by looking. So for part B, I just write d is greater than 9, and we're done there. 2025, Paper 1, Question 13. A function is defined a set of real numbers as this. The derivative of f dash x, is x plus 5x, 2x, 2 minus x. It says find the x-coordinates of the station points in the curve with y equals f of x in terms of nature. Now you might be thinking, you'll probably make a mistake here, and that's okay, because you're not usually given a derivative until to find stationary points, you're usually given y. If you're given a derivative, they've done the first step for you, so you're just finding the stationary points from there. So for part A, stationary points occur when f dash x equals 0, but I've already got f dash x, so I just write x plus 5, 2 minus x equals 0. Solving that, x equals minus 5, and 2 minus x is 0, so x is 2. So there's my stationary points, or at least the x coordinates, which is all we want. I do a nature table, along to minus 5 and along. Then I do another one, along to 2 and along. I'm looking at f dash x. So you're maybe subbing in minus 6 and minus 4, and you're maybe subbing in 1 and 3. So up to here, minus 6 plus 5 is minus 1. 2 minus minus 6 is 8. So you've got a positive number here and a negative number here. So you get a negative in total. So that's minus and that's 0. I'm going to expect a positive next, but let's just check. Minus 4 plus 5 is positive. And then 2 minus minus 4 is also positive. So a positive times a positive is a positive. So that's that one. And then the other side, 1, that's 6. 2 minus 1 is 1. That's positive and positive. That's positive then. That's 0. 3, that gives me 8. So that's positive. And 2 minus 3 is negative. So that's minus. So we've now got down, along, up, along, down. So x equals minus 5 as a minimum turning point, and x equals 2 as a maximum turning point. And we're done there for part A. Part B, it is known that f is a cubic function. F of 0 is less than 0. In the equation, f of x has exactly one solution between minus 10 and 10. Draw a sketch. Okay, so it's a cubic, so we know it's got 2 turning points, which we already know anyway because we just did it and we've got 2 turning points. F of 0 is less than 0 is saying that on the y-axis, it cuts the y-axis at a negative number. So y-intercept is negative. And the next one, the equation f of x equals 0 has exactly one solution. Now you might have been thinking here, oh, I remember this. Turning point touches the x-axis means it's 1, but that's not just true. It's not, that doesn't tell you that the whole thing has only one solution. If the whole thing only has one solution, it means that it only cuts the x-axis once and once only. So bear that in mind. So x-intercept just once. And we've already worked out our turning points, remember. Turning points are minus 5 and 2, and we know they're mins and maxes. So for part B, if I want to try and draw a sketch of this, and this is a little bit tricky, I'm not going to lie. There's your x, and there's your y. It cuts the y-axis down here somewhere, and if we go along to 2, we've got a max, and if we go to minus 5, we've got a min, and between some number minus 10 and 10, it cuts the axis somewhere. Examine what could happen. Imagine our turning point, this one's a max, is up here. If it's up there, it can never work because it cuts twice. So there you go. If our max was there, just touching and hugging, then it's going to cross over this axis and then it's going to turn around again because that's a minimum. So you're going to touch twice. So the only way it can ever work is if we're underneath there and then we come around and then we turn and the bit where it's cutting the x-axis is over there. So that's what I'm going to do. So we could have something like we go down, we come up, and we go back down. A nice curve like that, something similar to that. And you can see we've cut the y-axis and we could save it just to be on the safe side. Minus 10 is outside of there, just to show that we know that it's between before minus 10. But that's the only valid solution.
SQA Higher Maths 2018, Paper 2, Question 4. Express minus 3x squared minus 6x plus 7 and ax plus b squared plus c. So completing the square on this. So we take our function and we take the common factor out, which is minus 3 of the first two terms. So that gives us minus 3. We've got x squared then plus 2x, because minus 3 times 2 is 6x, and then we've still got a plus 7 on the end. So completing the square on this bit, we get minus 3, half the term, so x plus 1 all squared, and take away 1 squared, 1 times 1. And then we've still got plus 7. So that gives me minus 3, x plus 1 squared, minus 1, plus 7, and then expanding that bracket, that's minus 3x plus 1 squared. 3 times 1 is 3, is minus times a minus, so it's plus 3 plus 7. And then finally, our final answer, minus 3x plus 1 squared plus 10. And we're done there.
Increasing and decreasing functions, SQA Higher Maths, 2019, paper 2, question 7. Express this in the form p x plus q squared plus r. Now let's complete the square. So for part A, if we look at these two, we can take minus 6 out as a common factor. So we get minus 6, and we get x squared minus 4x. 6 times 4 is plus 24. Take away 25, sitting on the end, and then we just complete the square the normal way on this term. So we've got, that gives you minus 6, half the middle term, x minus 2, all squared, and then immediately take away 2 squared, and we've still got minus 25 on the end. Just be aware that this is all times by minus 6 though, so we need big brackets around it. So that gives us minus 6, x minus 2 squared. 2 2's is 4, 4 6's is 24. So we get plus 24 minus 25 sitting on the end. So that's minus 6, x minus 2 squared. 24 minus 25 is minus 1. Part B says, given that f of x is minus 2x cubed plus 12x squared minus 25x plus 9, show that it's strictly decreasing. So to show that something's increase or decrease, we need to evaluate the gradient of the tangent, and always differentiate. So let's look at f dash x. F dash x equals 3 times 2 is 6, so minus 6x squared. 12 times 2 is 24, so plus 24x, and minus 25. So we've differentiated it. But notice that is minus 6x squared plus 24x minus 25 is exactly what we were asked to do with something with completing the square on part A. So it's to do with the fact that it's completed the square. So we can now just say that f dash x now equals minus 6x minus 2 squared minus 1. If I pick any number for x here and I square it, I get a positive number. So that means I can then say x minus 2 squared is positive for all values of x. And that means that when I've got a positive times a negative is a negative. Take away another one, gives me a negative as well. So all I need to then say is, therefore, minus 6x minus 2 squared minus 1 is negative for all values of x. So f of x is strictly decreasing. And we're done there.
Okay, completing the square. SQA Higher Maths 2015, paper 2, question 2. The functions f of g are defined on suitable domains by these. First of all, it's a composite function question, but then there's a bit of completing the square at the end. So part A, f of g of x. Well, f of x is 10 plus x, so that's 10 plus g of x. So that's 10 plus 1 plus x, 3 minus x, plus 2. We need to tidy that up a little bit. So I'll expand the brackets. That's 10 plus 1 times 3 is 3, minus x plus 3x is plus 2x, minus x squared plus 2. So that equals 10 plus 3 is 13, plus 2 is 15. So it's 15 plus 2x minus x squared. Or you can write that minus x squared plus 2x plus 15. But I'll just leave it there. Part B, I've got f of g of x equals minus x squared plus 2x plus 15. So taking minus 1 out of the common factor of the first two terms, I get x squared minus 2x. I've still got plus 15 on the end. So that gives me minus 1 x minus 1 squared, half the middle term, and then take away minus 1 squared. I've still got plus 15. So that gives me minus 1 x minus 1 squared, take away 1, plus 15, which is minus x minus 1 squared. Minus 1 times minus 1 is 1, so 1 plus 15 is 16. And that's it in completed square form. C says another function h of x is 1 over f of g of x. What values of x cannot be in the domain of h? So part C, h of x is 1 over f of g of x, which we've just completed the square of, so it's 1 over minus x minus 1 squared plus 16, or otherwise, but the denominator cannot be 0. So we can just write that for the domain, for that to be valid, the denominator cannot be 0. So that implies minus x minus 1 squared So try to solve that equal to 0 to see what that gives me for it. When it is 0, I can then say x can't be these numbers. So we've already completed the square, so we can just say minus x minus 1 squared equals minus 16. Divided by minus 1 means x minus 1 squared equals 16. Square root on both sides, then you get x minus 1 equals 4 or minus 4. So that means x either equals 4 plus 1 is 5, or x equals minus 4 plus 1 is minus 3. That means x cannot equal 5, or x cannot equal minus 3, and we're done there.
SQA Higher Maths 2024, paper 1, question 8. The equation x squared plus m minus 4x plus 2m minus 3 has no real roots. Determine the range of values for m. So if it's got no real roots, that means that b squared minus 4ac must be less than 0. So a is equal to 1, b is m minus 4, and c is 2m minus 3. So we're just going to sub that in. So we've got m minus 4 squared minus 4 times 1 times 2m minus 3, and that's less than 0. So that's m squared minus 8m plus 16, take your time expanding. 4 times 1 is 4, times 2 is 8, so minus 8m. And then minus times a minus is a plus, so plus 12, less than 0. So that gives me m squared minus 16m, and then plus 28 is less than 0. So this is a quadratic inequality. So what we do with these is we look at the roots and draw a little graph. So the roots, we've got double brackets, m and m. And for the roots, we've got 14 and 2. Minus 14 minus 2 is minus 16. 14 2s is 28. So we get m equal 2 and m equal 14 as our roots. So we now draw a graph. Just a rough one. There's 14. There's 2. There's your quadratic. It was positive, yep. And we want it less than 0. So underneath here, that's between these two numbers. So our final answer is 2 is less than m is less than 14. And we're done there. SQA Higher Maths 2025, paper 1, question 11. The equation 9x squared plus 3kx plus k is 0 has two real and distinct roots. Find the values or range of values for k. So if we've got two real and distinct roots, the discriminant must be strictly greater than 0. Not even greater than or equal to, because if it's equal to 0, it's got two real and equal roots, and it's got two real and distinct. So what is our b? 9k. 3k squared minus 4 times 9 times k is greater than 0. That's 9k squared minus 36k is greater than 0. So to solve something like this, you look at the roots. It's just a quadratic inequality. And that gives me 9k squared minus 36k equals 0. 9k is a common factor to give k minus 4. So k is 0 from the first place, and k is 4. So that answers what the roots are, so I draw it. So we've got 0 and 4. It was a positive k squared. So it looks something like that, where that's 4 and that's 0. And it says we want to be greater than 0, so above the x-axis. Well, above the x-axis, I'm continuing that way, and I'm continuing that way. So our final answer is k must be less than 0, or k must be greater than 4 for the range of values. And we're done there.
Okay, we're discovering SQA Higher Maths 2018, Paper 2, Question 10. The equation m squared plus m minus 3x plus m equals 0 has two real and distinct roots. Determine the range of values for m. So, two real distinct roots. That implies that b squared minus 4ac must be greater than 0. So in this case, our a is the number in front of x squared, which is 1. Our b is the number in front of x, which is m minus 3. And our c is what's left at the end, which is just m. So being careful, subbing this in, we get m minus 3 all squared minus 4 times 1 times m is greater than 0. So we need to then expand our brackets. So that is m squared minus 6m plus 9. And then 4 times 1 is 4 times m. So minus 4m is greater than 0. So that gives me m squared minus 10m plus 9 is greater than 0. So we need to examine the roots. So looking at the roots, we can try and factorize this. We've got double brackets, m and m, 9 and 1, minus 9 minus 1 gives you minus 10. So the roots have m equal to 1 and m equal to 9. And now we need to draw a graph to examine when is the inequality greater than 0. So that's why we look at the roots. So we'll draw a quick graph. We put our roots on at 1 and 9. We know that the shape goes down the way because it's a positive m squared, so we can just draw a quick sketch of a graph. It doesn't have to be anything too fancy. And we're looking at when it's greater than 0, so I'm looking at when it's above the x-axis. So using a different colour pen, it's above the x-axis over here, and it's above the x-axis over here. In other words, when m is less than 1, or when m is greater than 9. And that's our final answer. Okay, looking at quadratic inequalities, SQA Higher Maths 2015, Paper 1, Question 8. ABCD is a rectangle with lengths x and x minus 2 as shown. If the area is less than 15, determine the range of values of x. Well, area is length times height. So I'll just write that down, or length times breadth if you prefer. So our length is x, and that's x minus 2. And it says that that area has to be less than 15. So I'll just write x minus 2 is less than 15 to set up my inequality. Expanding my brackets, I get x squared minus 2x is less than 15. I've got a quadratic, so I need to take the 15 to the other side. And we need to then find out the roots and draw a graph to see where it's less than 0. So looking at the roots of this, we've got x squared minus 2x minus 15. If that's factorizable, hopefully, we get x and x, 5 and 3. Minus 5 plus 3 is minus 2, so roots are x equal to minus 3 or x equal to 5. So that means we can draw a quick sketch at the side. Minus 3 is over here, and 5 is over here somewhere. It's positive x squared, so our quadratic looks something like that, and it just has to be a quick sketch. Now we're looking to see where it's less than 0, where it's less than 0 below the x-axis. So that is in between these two numbers. Minus 3 is less than x is less than 5. But we need to be careful with this question because it is about the area of a rectangle, so we can't have a negative length. X must be, let's have a look. We've got x minus 2 is our smallest, so it has to be bigger than 2. Or the breadth would be negative. And therefore, our actual answer is 2 is less than x is less than 5. Need to be very careful with ones where it's in context.
SQA Higher Maths, Paper 1, Question 3. Circle C1 has this equation and C2 has centre 4 minus 2. The radius of C2 is equal to the radius of C1. Find the equation of circle C2. So we have got our equation up here, and just remember, from our equation, x squared plus y squared minus 2x minus 2y minus 26 equals 0. You're given at the start of the exam paper the radius. The radius is quoted as equaling the square root of g squared plus f squared minus c. And your g and your f, well, this is called 2g and 2f. So 2g is minus 6 and 2f is minus 2. So my g is minus 3 and my f is minus 1. So my radius is equal to minus 3 squared plus minus 1 squared. Take away c, but it's a minus already, so plus 26. So that means that going down here, my radius is equal to the square root of 9 plus 1 plus 26. That's the square root of 36, which is equal to 6. So we've got our radius, and we know the circle centre is 4 minus 2. So we know the equation of C2 must equal x minus 4 squared plus y plus 2 squared equals 36. And we're done there.
SQA Higher Maths 2016 Paper 1 Question 4 on the circle. A and B are points 7, minus 3 and 1, 5. Let's just take a note of that. So there's A, minus 7, 3, and B is 1, 5. Find the equation of a circle. So for the equation of a circle, we need two things. We need the centre and the radius. So where's the centre? It's in the middle of these 2 points. So the midpoint of A and B, let's just call that midpoint of A and B. We add the x parts, minus 7 plus 1 over 2. We add the y parts, 3 plus 5 over 2. Minus 7 plus 1 is minus 6, divided by 2 is minus 3. And 3 plus 5 is 8, divided by 2 is 4. So we've got a midpoint. We now need our radius. So to get our radius, we use the distance formula. So we now know we've got minus 3 and 4. So the distance, let's just call this m. The distance between m and say b is Pythagoras, the square root of minus 3 minus 1 squared plus 4 minus 5 squared, all the other way round. That's the square root of minus 4 squared plus minus 1 squared. That's the square root of 16 plus 1 is 17. So the distance is 17. So now using the start of our exam paper, x minus a squared plus y minus b squared equals r squared. So our centre is minus 3, 4. So that's x plus 3 squared plus y minus 4 squared equals root 17 squared, which is just 17. And we're done there.
SQA Higher Maths 2018, Paper 1, Question 4. The point K lies on the circle with this equation. Find the equation of the tangent to the circle at K. Tangent meets a radius at right angles. So we need to find the centre of our circle. So we've got it in expanded form. So from the start of the exam paper, we are told that x squared plus y squared plus 2gx plus 2fx plus c equals 0 is the equation of a circle where the centre
is equal to minus g minus f, and the radius is equal to the square root of g squared plus f squared minus c. So looking up at our equation, the number in front of f, 2g, is minus 12. And the number in front of y, 2f, is minus 6. So that gives me g is minus 12 divided by 2, minus 6. And it gives me f is minus 6 divided by 2, minus 3. So our centre is just simply 6, 3. Once we've got our centre, we can find the gradient between our centre. Let's just call our centre C. So the gradient between C and K is minus 5 take away 3 on the top and 8 take away 6 on the bottom. Minus 5 take away 3 is minus 8 over 2, which is minus 4. So the gradient of our perpendicular equals a quarter, since m1 times m2 equals minus 1. So our point is 8 minus 5 for K. So we can use y minus b, y plus 5 equals m x minus a, which is 8. Times it through by 4, we get 4 times y plus 5 equals x minus 8. So 4y plus 20 is x minus 8, or to leave it in a nice way, 4y minus x equals minus 28 would be a fine answer. If you prefer y equals, you can divide through by 4 to get y equals a quarter of x, and then minus 28 divided by 4 is minus 7 if you prefer. Okay, SQA Higher Maths 2015, paper 1, question 11. T minus 2 minus 5 lies on the circumference of the circle with this equation. Find the equation of the tangent to the circle passing through T. So let's work out the equation of the tangent. If we draw a little picture, just to give us an idea of what's happening, let's say that T is here, and we'll call that minus 2 minus 5, and this is not an accurate picture. Then we've got our centre of our circle where we can work out our centre. It's minus 8 minus 2. And we have to find the equation of a tangent passing through T. So a tangent makes a radius at right angles. From National 5. So if we work out the gradient between the centre and T, then m1 times m2 equals minus 1. So the gradient, I'll just call this the centre C, between C and T, equals minus 5 minus minus 2 over minus 2 minus minus 8. That's minus 5 add 2 is minus 3. Minus 2 add 8 is 6. So that's minus a half. So therefore the gradient of our perpendicular equals 2, since m1 times m2 equals minus 1. So we've got our gradient of 2, and then we can use our point. So y minus b equals mx minus a as usual. The point obviously we're using is t. So it's y plus 5 minus minus 5 equals 2x plus 2. Multiplying that out, we get y plus 5 is 2x plus 4. So y equals 2x minus 1 is the equation of our tangent. B says the tangent is also a tangent to a parabola with equation y equals minus 2x squared plus px plus 1 minus p. Determine the value of p. So we've got y equals 2x minus 1, and then for part B, we've also got y equals minus 2x squared plus px plus 1 minus p. And since this is a tangent to this, then these are equal to each other. We can solve them simultaneously. So all we need to do is say that 2x minus 1 equals minus 2x squared plus px plus 1 minus p. So that's a quadratic to solve. So moving everything over to the same side, or just move everything over to the right, we get 2x squared plus 2x minus px, then minus 1, then minus 1 again, and then plus p, and that equals 0. Tidying that up, squared, and then we want to have x as a thing, so that is plus
2 minus p times x, and then we've got as a constant term minus 2 plus p equals 0. Now, if it's a tangent, b squared minus 4ac equals 0. Because it only has one solution. So that means we can say, remember, that would be our A, this would be our B, and this whole thing here would be our C. So we can say that we've got 2 minus p all squared minus 4 times 2 times minus 2 plus p equals 0. Solving that, multiplying out the bracket, we get 2 2's is 4 minus 4p plus p squared, and then we've got minus 8 times minus 2 is plus 16, and then we've got minus 8 times p, so minus 8p equals 0. Continuing on to solve this then, we've got p squared minus 12p plus 20 equals 0. So another quadratic to solve, but this one should be factorizable, hopefully. Double brackets, we've got p and p. 10 and 2 make 12 when you add them, so it's 10 and 2 minus 10 minus 2. So p equals 2 or p equals 10. But then if we go back to the original question, it says p is greater than 3. So we're disregarding this one. P equals 10 as our final answer.
SQA Higher Maths 2024, Paper 1, Question 7. The line y equals 2x is a tangent to the circle x squared plus y squared minus 14x minus 8y plus 45. Find the coordinates of the point of contact. Well, finding the point of intersection means solving simultaneous equations, so I'm just going to sub it in. So I've got x squared plus y squared, which is 2x, minus 14x, minus 8y, so it's 8 times 2x, plus 45 equals 0. And we'll just solve that for x. So that's x squared plus 4x squared minus 14x minus 16x plus 45. That's 5x squared, and that's minus 30x, and that's 45. So 5 is a common factor, x squared minus 6x plus 9. Remember, this is a tangent, so if you get more than one answer, you've made a mistake here. So watch out. You could just complete the square, but I can see here that I can just factorize it. Half the term, that's 3 and 3, minus minus. Minus is a minus is a plus, that's plus 9. Minus 3 is minus 6. So you get x equals 3 as your x coordinate, and therefore y equals 2 times 3, 2x, which is 6. So your point of contact is 3, 6, and we're done there. SQA Higher Maths 2025, Paper 1, Question 9. Find the coordinates of the point of intersection of the line with the equation x plus 1 in the circle x squared plus y squared minus 2x plus 6y minus 15 equals 0. So we sub in x plus 1. So we've got x squared plus x plus 1 all squared minus 2x plus 6 times x plus 1 minus 15 equals 0. That gives me x squared plus, square out that bracket, x squared plus 2x plus 1, you can use double brackets for that, minus 2x plus 6x plus 6 minus 15 equals 0. So how many x squares have I got? I've got 2 of them. For x's, I've got 2 minus 2 is 0 plus 6. And for numbers, I've got 1 plus 6 is 7 minus 15, which is minus 8. So we can see that 2 is a common factor. X squared plus 3x minus 4. And hopefully that factorizes to give us x and x, 4 and 1. And it's going to be plus 4 minus 1 to get plus 3 in the middle. So x equals 1 or x equals minus 4. Find the coordinates of the points of intersection. Well, I've got my x's, I need my y. Y was x plus 1. So when x equals 1, y equals 1 plus 1 is 2. So that's 1, 2. And when x equals minus 4, y equals minus 4, add 1, which is minus 3. So we get minus 4 minus 3. And we're done there. SQA Higher Maths 2023, paper 2, question 15, the last one. The line x plus 3y equals 17 is a tangent to a circle at the point 2,5. And it also says the centre of the circle lies on the y-axis. So if we imagine this is a y-axis here, somewhere that centre is on that y-axis. So now it asks us to find the coordinates of the centre of the circle. This is quite a tricky one, this one, but let's just start dealing with it. Where's our centre here? We know that the radius meets the tangent at right angles. So if I knew the gradient here, I would automatically know this. So let's start on that point. We've got x plus 3y equals 17. 3y then equals minus x plus 17. Y equals minus a third of x plus 17 over 3. The gradient of that is minus a third, and therefore the gradient of the perpendicular is equal to 3 because m1 times m2 equals minus 1. We also know that the centre of the circle lies on the y-axis. So if it lies on the y-axis, it goes along 0. So if I draw an x-axis in, we don't know where this x-axis is, so I'm not going to put it there. That's like our x-axis. It goes along 0 and up some number, call it c. But we know our gradient is 3, and we've got 2 points, so we can use the gradient formula and work out our c. So let's just do that. We've got 0c and we've got 2, 5. So y2 minus y1, 5 minus c equals 2 over 2 minus 0 equals our gradient of 3. So we've got 5 minus c over 2 equals 3. 5 minus c equals 6. So I'll just take the 5 over minus c equals 6 minus 5. 6 plus 5 minus c equals 6 minus 5, which is 1. So c equals minus 1. So the centre of the circle is simply 0 minus 1. And we're done there.
Okay, SQA Higher Maths 2016, paper 1, question 8, the intersection of lines and circles this time. Show that the line with equation y equals 3x minus 5 is a tangent to the circle with this equation and find the coordinates of the point of contact. So if it is a tangent, it means this y is equal to the y in here. So I can substitute this into this equation. So I've got x squared plus 3x minus 5 squared plus 2x minus 4 times 3x minus 5 equals 0. So multiplying out our brackets, we get x squared plus 3 3s are 9, so 9x squared. 3 5s is 15 times 2 is 30, so minus 30x plus 25 plus 2x. 4 3s is 12. So minus 12x, 4 5s is 20, so plus 20, then minus 5 equals 0. So you're going to get a quadratic. So we've got x squared plus 9x squared is 10x squared. Minus 30x plus 2x is minus 28x. Minus 12x is minus 40x. And then we've got our number part, 25 plus 20 is 45 minus 5 is 40. And we know that that equals 0. So we can solve that by taking 10 out as a common factor to get x squared minus 4x plus 4 equals 0. And then let's solve it. Now we're looking if it's a tangent for only one solution because it only touches it at one point. So this should be equal roots. So let's check x and x. 2 2s is 4, so minus 2 equals 0. So we can say that it's got equal roots. So only one point of contact. Therefore, the line is a tangent to the circle. Find the coordinates of the point of contact. Well, I've already got this equation equal to 0, so that implies that x equals 2. And then subbing that back in to get our y, well, we might as well just use our original equation, y equals 3x minus 5. So we've got y equals 3 times 2 minus 5. 6 minus 5 is 1, so we've got 1 and 2. So our point of contact is 2, 1. And we're done there.
SQA Higher Maths 2024, Paper 1, Question 13. P and Q are the points 4, 10, 6, 2, and find the equation of the perpendicular bisector of PQ. So there's PQ there. Perpendicular bisector means it cuts it in half at right angles, as you can see. So I need the midpoint. So for part A, I need the mid of PQ. Well, that is 4 plus 6 over 2 and 10 plus 2 over 2. 4 plus 6 is 10, divided by 2 is 5, and 10 plus 2 is 12, divided by 2 is 6. So I've got my midpoint, and now I need the gradient. Well, it's perpendicular, so I can find the gradient of PQ and use m1 times m2 is minus 1. So y2 minus y1, so it's 2 take away 10, all over 6 take away 4. 2 take away 10 is minus 8, 6 take away 4 is 2, so that gives me minus 4. So that means the gradient of the perpendicular equals 1/4, and I need to say why I know that. m1, m2 equals minus 1. So now I can do my equation. Y minus b, that's 6, 1/4, x minus 5. Take the 4 up to the other side and get x minus 5 on this side. So that's got 4y minus 24 is x minus 5. Leave it in any form you want, but I'm going to do 4y minus x and just take a 5 over. Minus 24 plus 5 is minus 19, and that'll equal 0. And that'll be fine for that one. R has coordinates 12, 2. The circle passes through the points PQR, and QR is a horizontal chord. It's horizontal. So if you imagine this is also a chord, and this is the diameter of the circle. Should be obvious that's the diameter because it's cutting a chord in right angles and at half. So that is definitely the diameter. So there's the centre of our circle there. Let's call that C. Now if I was to drop that down at right angles and cutting that in half, that means that I would have the x part of the coordinate, and I can just sub in my equation and get the y part to get the centre. So that's what I'm going to do. The mid of QR. So part B, the mid of QR is equal to, we've got 6, 2 and 12, 2. So 6 plus 12 divided by 2 and 2 plus 2 divided by 2. 6 plus 12 is 18, divided by 2 is 9, so we get 9, 2. So when x equals 9, that's going to be for our centre, we get 4y minus x, which is 9 minus 19 equals 0. So 4y minus 28 must equal 0. So y is 28, no 4y is, stupid. So that means y is 28 divided by 4, which is 7. So we now know our centre is equal to 9 and 7. Now what about our radius? Well, there's 9, 7 there. Just use a point on the outside. Let's just use this one to get our radius. So the radius is 410 to 97, the distance. So for our radius, which we'll just do squared, I'm going to use 410 and I'm going to use the centre 9, 7. So distance between 9 and 4, so 9 minus 4 squared, and the distance between 7 and 10, 7 minus 10 squared, or 10 minus 7. I'm just going to do it squared because I'm going to use keep it as r squared anyway. 9 minus 4 is 5 squared, 7 minus 10 is minus 3 squared, so r squared is 25 plus 9, which is 34. So that means now we've got our radius squared and our centre was 9, 7. So the equation of the circle is x minus 9 squared plus y minus 7 squared equals 34. And we're done there. For paper 2, question 10, circle C1 has the equation x squared plus y squared plus 18x minus 2y minus 8 minus equals 0. Find the radius and centre. So start the exam paper for this. Usually for part A, I'll just do it here actually. You would say 2g equals the number in front of x
18, and 2f equals the number in front of y minus 2. So g is 9, and f is minus 1. And from the start of the exam paper, the centre is minus g minus f. So that is equal to minus 9 and 1. Now we want our radius. So from the start of the exam paper, the radius is the square root of g squared plus f squared minus c. I usually remember it like this. The square root of the centre numbers added together, take away the last number. So minus 9 squared and plus 1 squared and minus 8, so plus 8. So that equals the square root of 9 nines are 81, 1 ones are 1, plus 8. 81 plus 1 is 82, plus 8 is 90. All surds should be simplified in higher maths. Root 9 root 10. That's 3 root 10. So there's our radius and there's our centre. And we're done there. Part B says, the second circle C2 touches C1 internally. The centre of C2 is minus 6, 0. Determine the equation of C2. Well, there's our new centre for this big circle, minus 9, 1. Now, if you imagine taking the centre of this and the centre of that, if I did this big one minus that one, it leaves me what's in between, which is, well, the distance between the centres. So we can use that fact quite handily, that the radius of the big one minus the radius of the small one equals the distance between the centres. We're going to say that R2 minus R1 equals D, because they touch internally. So we already know R2, it's 3 root 10. We don't know R1, but do we know D? Well, we've got two coordinates. Distance formula, so D equals the square root. We've got minus 9 minus 6, or the difference between minus 9 and minus 6, and the difference between 1 and 0. The difference between minus 9 and minus 6, minus 9 plus 6 is minus 3, that's squared of course. Square root of minus 3 squared plus 1 squared, that's 9 plus 1 is 10, root 10. So that equals root 10. R1 over to this side, you get 3 root 10 minus a root 10, so R1 equals 2 root 10. So now we've got a radius and we've got its centre, so the equation from the start of the exam paper is x minus a squared plus y minus b squared equals r squared. X minus 6 plus 6 squared plus y minus 0, so plus y squared equals, careful, 2 root 10 all squared. So working that out, I get x plus 6 squared plus y squared equals 2 2's is 4, root 10 times root 10 is 10, so that's 40, and we're done there.
SQA Higher Maths 2025, Paper 2, Question 14. This was a doozy, this one. I think a lot of people found this hard, so let's get into it. Circle C1 has equation x plus 5 squared plus y minus 6 squared equals 9. Find the centre and the radius. Okay, so the centre is easy enough of C1. That's just x plus 5, so minus 5, y minus 6, so plus 6. And then the radius is the square root of 9, which is 3. So nothing major there. C2, that's radius as well. So minus g minus f. So 2g is 14, well, minus. So g is minus 7. 2f is 6, so f is 3. So it's minus g minus f, 7 minus 3. The radius is the square root of 7 squared plus minus 3 squared minus the 54 in the end. This is just all from the start of the exam paper, of course. 7 sevens is 49, 3 threes is 9. 7 sevens is 49 and 3 threes is 9. Minus 54 is 4, so the radius of that one is 2. So R2 is 2. We'll call that R1. Now we're done there. We'll get to part C now. C says, circle C1, C2, C3 are touching as shown in the diagram. The centre of C3 lies on the line joining the centre of C1 and C2. Determine the equation of C3. And I think this is where a lot of us will go, what do I do with this? This is the last question of the paper. It is designed to be difficult, okay? So don't worry too much. But let's see what we already know. R1 was 3, remember, and R2 is 2, and C1 was minus 5, 6, and C2 was 7 minus 3. So we've got all that information to start with. So let's just shove some stuff on here. I need the center and I need the radius of this, okay? So the first thing I'm going to do is try and work out the radius by looking at the distance between C1 and C2, because I've got two centers. So the distance of C1 to C2, distance formula of Pythagoras, you've got 7 and minus 5, the difference between them is 12. And then you've got 6 and minus 3, the difference between them is 9. 7 minus 5 is 12, minus 3 minus 6 is 9. 12 squared plus 9 squared is 225, which square roots to 15. You check out yourself, I just know that one. So we know that the radius, the distance between centers is 15. So how does that help me get the radius, you might be wondering. So I've worked out my distance between the centers, so I now know that this whole line here is 15. So how am I going to get my radius? Well, I know nothing about this bit. But what I can do is I can say, well, look, what if I tried to go for the diameter? If I went all the way along here, I would have the distance plus an extra 3, but then I would be that many too far, so I'd have to take away 2. So it's the whole distance between the centers plus the 3 take away the 2. So the diameter is 3 plus 15 take away 2, which is 15, 16, 17, 18, minus 2 is 16. So the radius C3 is half of that, which is 8. So I've got one bit of the information now. This whole line, we know that now that this bit's 8, and then we've got 2 extra, so that's 10. And what about the other side of that line? Well, we've got 3 to this point, and we know that the radius of this thing here is, well, the distance between centers is 15, so that must be 5. So it must be 5 and 10. So I'm going to draw that out on a straight line for you. If I just draw it as like this, and that's C1 there, C3 somewhere, and C5, since we know the whole line is 15, and since we know the distance between here and here is 10, then we know the distance between here and here must be 5, because the distance between the centers is 15. So now that we've got that, we can just use vectors to work out our center. Now you can use the section formula, but I don't like the section formula. So I'm just going to use vectors. C1 was minus 5, 6. And C2, was 7 minus 3. And I want to work out this one. So let's call that x, y, z for the sake of it. Then I know that if that's 5 to 10 as a ratio, I can simplify that to 1 to 2. So far, so good. So x to y over y to z equals 1 to 2, 1 over 2. That's what I'm thinking about. So that means that y to z equals 2xy. So y to z is z minus y equals 2y minus x. And I'm trying to get y because that's what I've called a middle point or vector. So z minus y equals 2y minus 2x. So if I take the y over here, I get 3y, and I get z plus 2x. So finally, y is z plus 2x over 3, or a third of z plus 2x. Well, we've got z and x. Z is 7 minus 3, plus 2 of x. X is minus 5, 6, so that's minus 10, 12. That's a third. 7 minus 10 is minus 3. Minus 3 plus 12 is 9. A third of that is minus 1 3. So that means that our point, centre, C3 we're calling it, is minus 1, 3. And we know its radius now already, way back up here. I think we worked out it was 8. So we need to know the equation then. X minus 1 plus 1 squared plus y minus 3 squared equals 64. And finally, we're done there.
SQA Higher Maths 2015, paper 2, question 5. Circle C1 has equation x squared plus y squared plus 6x plus 10y plus 9 equals 0. And the centre of C2 is 9, 11. There's C2 there, so let's just call that 9, 11. And the touch, determine the radius of C2. Well, we'll just find out all we can, so let's see if we can find the centre of C1. We have got this equation here, and we know from the start of the exam paper that minus g minus f is a circle's centre, so to get minus g minus f, you just divide these by 2 and change the sign. So that becomes 3, 5, so that's minus 3 minus 5. So we can write that for that centre. What else do we know? Well, we also know the radius of C1. So if we knew the radius of C1 and maybe this whole distance, we could find the radius of C2. So let's do the whole distance first. So the distance between, let's call it C1 and C2. Distance formula is Pythagoras, so it's 9 minus 3 squared, the x's, plus 11 minus 5 squared. That equals the square root of 12 squared plus 16 squared. That is 400, which gives me 20. So we now know the distance all the way up here is 20. So let's now find the radius of circle C1. So again, start of the exam paper, radius is equal to the square root of g squared plus f squared minus c. So we know g and f are just our centres. So therefore we can say the radius of C1 or R1 is equal to the square root of 3 squared is g plus 5 squared is f minus c, which is minus 9. So that is 9 plus 25 minus 9 is 25. So therefore the radius R1 is equal to 5 units. So we now know, I'll just use a different colour, that from here to here is 5. And therefore from there to there must be 15. Therefore R2 equals 20 minus 5, which is 15. And we're done there.
So it now says,
for part B, a third circle is C3 is drawn such that C1 and C2 touch internally with C3, and the centres of C1, C2, C3 are collinear, so they line up in a straight line. And we have to determine the equation of C3. A little sketch to illustrate this will be handy for you. This point here is minus 3 minus 5, and we know that the other point is 9, 11 here. And we want to know where the centre of the big circle is, and therefore what its radius is. So we're kind of looking at this line going through. Now we know the radius as well of C1 is 5, so we know that this line here is 10. We're going to go 5 on this side and 5 on that side. And we also know the radius of our big circle now is 15, or our big one in the middle. So that's 15 and 15. So we can use ratio to see how much the line divides the circles. So you should be able to see that a centre of the big circle, if I just kind of do it there, is kind of roughly there. So if I kind of mark that point, that's the centre of like C3 roughly there. And we need to know where that is. So let's see how we divide this up. So if I kind of just draw a right angle triangle here, there it is. You can see that this distance is going from minus 3 all the way over to 9. So that's 12. And we can see that this distance is from minus 5 all the way up to 11. So that's 16. So the diameter of a big circle is 30 plus 10, which is 40. So the radius of a big circle is 20. So we know that from the big circle from here to there is 20. Or just like that, the radius of 3 is 20 at the side. So we know that this bit here is like 5. So this bit in here must be 10 because it goes 10 plus another 10 makes 20. So that must be 10 in there. So if we think about moving from here to here, we move 15 units. And then from here to here, we move 5 units. So the ratio is 3 to 1. So if we divide 12 by 4, we get this line must be 3. And if we divide 16 by 4, this line up here must be 4. That must be a 3, 4, 5 triangle there. So then we can get the centre just by working backwards from 9, 11. It's taking 9, 11. Our centre, which I'll just do in a different colour. 9 minus 3 is 6. And 11 minus 4, 7. So we get our centre of our circle finally is 6, 7. So we've got our centre and we've got our radius. So the equation is x minus 6 squared plus y minus 7 squared equals 20 squared. And we're done there. Or we can say x minus 6 squared plus y minus 7 squared equals 400. Okay, unusual circle questions, SQA Higher Maths 2019, paper 1, question 16 had this one. P is the point with coordinates 4k and C is the centre of the circle with this equation. Show the distance between P and C is given by square root of k squared plus 4k plus 13. So part A, we've got our points 4 and k and the centre of our circle is equal to, well, let's have a look. We've got 1 minus 2. So we can work out the distance between them. That is going to be the square root of the difference in the x's, 4 minus 1 squared, plus the difference in the y's, k minus minus 2 squared. Tidying that up, we get the square root of 3 squared plus k plus 2 squared. That equals the square root of 9 plus k squared plus 4k plus 4, which equals the square root of k squared plus 4k plus 13 as required. Part B says, hence otherwise find the range of values of k such that p lies outside the circle. So let's draw a little picture for this. We've got a circle and the centre of that circle is 1 minus 2. And we can look to see what the radius is. We know the radius is 5, the square root of 25. So that distance is 5, that's our radius. So if P is outside the circle, then clearly the distance between the centre and P must be bigger than 5. It has to be over 5. So we can then just say that the square root of k squared plus 4k plus 13 is greater than 5. And we can go from there. That's because our radius, remember, is 5. So, quadratic inequality, square both sides, k squared plus 4k plus 13 is greater than 25. Taking the 25 over, we get k squared plus 4k minus 12 is greater than 0. And this is a quadratic inequality, so we examine the roots. So looking at our roots, we've got k squared plus 4k minus 12 is equal to 0. Double brackets, we get k and k, 6 and 2, plus 6 minus 2 is 4. So our roots have to make k equal to 2, or k equals minus 6. Drawing a quick sketch then of that graph, we get 2's over here somewhere, minus 6 over here. It's a positive k squared, so it is a happy face. We don't need the turning point or anything because we're just looking to see when is this bigger than 0. Well, it's bigger than 0 above the x-axis, so it's over this side, it's always bigger than 0, and over this side, it's always bigger than 0 as well. So our final answer is k is less than minus 6, or k is bigger than 2. And we're done there.
SQA Higher Maths 2025, paper 1, question 3. Integrate 12 over x squared plus x to the half dx. So I need to get it ready to integrate. So that's 12x to the minus 2 plus x to the half dx. Add 1 to the power, divide by the new power. Minus 2 add 1 is minus 1. Divide by minus 1 gives me minus 12. Add 1, so that's 3 halves. And when you divide by 3 halves, it's the same as doing 2 thirds. And then you've got plus c. And really, that's it. But I'll probably make it look neater, just for the sake of it. it doesn't tell you to really do anything with positive powers or anything. Minus 12 over x plus 2/3 x to the 3/2 plus c. You could do as much as you want with that, or as little as you want with that. You could do, if you really wanted to, minus 12 over x plus 2/3, and it would be the square root of x cubed plus c, but I don't really see any need to do that. And we're done there. SQA Higher Maths 2023 Paper 1 Question 6. Integrate 2x to the power 5 minus 6 root x dx for x greater than or equal to 0. So integration without limits means there's going to be a plus c, but I need to get it ready to integrate. Root x becomes x to the half. So I'm going to integrate 2x to the 5 minus 6x to the half dx. So integrate, add 1 to the power, divide by the new power. So x to the 5 becomes x to the 6, and I've got 2/6 minus 6x, add 1 to a half, you get 3/2. So I have to divide by 3/2, and I've still got plus c. So dealing with the first one is easy. 2/6 is a third, so we've got a third x to the 6. Divided by a fraction, same as times by its reciprocal. So times by it and then turn it upside down. So I've got minus 6 times 2/3 x to the 3/2 plus c. So that gives me 1/3 of x to the 6. 6 2s are 12. 12 divided by 3 is 4. So minus 4 x to the 3/2 plus c for our final answer. SQA Higher Maths 2024 Paper 2 Question 5. Evaluate the integral between 0 and pi over 7 of sine 5x dx. A simple one this. Start of exam paper tells you if you integrate sine ax, you get minus 1 over a cos ax. So that's what I'm going to get. Minus 1 over 5, because that's my a, cos 5x, plus, well, not plus c because I'm putting numbers in. And that's the chain rule. What has happened here is you've the derivative of 5x, which is 5, and divided by it, and sine goes to minus cos. So now I just sub my numbers in as per usual. Minus 1/5 cos 5 pi over 7. That's one of them. Take away minus 1/5 cos 5 times nothing. I'll just put nothing in. Now, not expected to know these. Calculate a job. Make sure I'm in radians. So let's just check it's minus 1/5 at the front, right? So minus 1/5, 1 divided by 5 is 0.2, so I'm just going to do that. Minus 0.2 times cos bracket 5 pi over 7 is 0.1247, say. And minus, well, cos is 0, you should know is 1, but I mean, we've got a calculator here, so let's just check 1. So minus 1/5 times 1 is minus 1/5, so we've got a minus, minus 1/5. Well, 1/5 is 0.2, I've already established that. So it's 0.1247 plus 1/5, which is 0.3247. Or, if you wanted to round it, 0.325, I suppose, would be fine. And there's no degree sign or nothing like that. We're in radians anyway. So we're done there. SQA Higher Maths 2023 Paper 2 Question 3. Integrate 7 cos 4x plus pi over 3 dx. So we're going to use the chain rule here because we've got an inner function. So integrate cos. Well, cos goes to sine using the start of the exam paper. So that integral straight away becomes 7 sine 4x plus pi over 3, but then we need to divide by the inner function differentiated, so differentiate 4x, you get 4, pi over 3 is nothing, so it's just 4, and then we've got plus c, remember, don't forget the plus c. We could leave it like that, but I'm just going to tidy that up slightly by taking the fraction outside, so we get 4x plus pi over 3 plus c, and we're done there. SQA Higher Maths 2025, Paper 2, Question 7. Integrate 3x plus 2 to the power 7. All right, so this is the chain rule. 3x plus 2 to the power 7. I add 1 to the power is 8. I divide by the new power, 8. But you also divide by whatever's inside that bracket differentiated. You need to break the chain. 3x plus 2, differentiate it is 3. So there we are there. And then we've got plus c, of course. Don't forget your c. That's 3x plus 2 to the 8. 3x is 24, so I'll just write it as 1 over 24 for neatness, plus c, and we're done there. SQA Higher Maths 2025, paper 2, question 8. EABCD is a rectangular base prism with AD is shown, DC and DE. Find B to E in terms of IJK. So B to E, where's B? There it is. So I need to get all the way to E. So I could go along here. That seems reasonable. So B to C, which is the same as A to D. So let me write that down, 6, 4, 2. I always work in component form and change back. And then I need to go along here, which is the opposite direction of D to C. So minus 2, minus 4, and 2. And then I need to go up here to get to E, which is the same direction as D to E. So plus again, minus 4, minus 3, 4. So I'll work out my numbers. 6 minus 2 is 4. Minus 4 again is 0. 4 minus minus 4 is 8. 8 minus 3 is 5. 2 minus 2 is 0, plus 4 is 4. So in IJK form, I've got 0i plus 5j plus 4k, which you can just write as 5j plus 4k. And you're done there.
Okay, integrating a trig function again with a chain rule. We've got Higher Maths 2019, paper 1, question 11. Evaluate the integral between 0 and pi over 9 of cos 3x minus pi over 6 dx. Exact value question as well because it's non-calculator. So let's start integrating. That becomes cos goes to sine, remember? We're looking at the start of the exam paper. The whole function, 3x minus pi over 6. But then we need to differentiate this. Well, that's just a number, so that's nothing. That becomes 3. So divide by 3. And that is the integral between 0 and pi over 9. So there's our first step. Now we need to just substitute in. So that gives us a third of sine, well, 3 times pi over 9, we'll just write, minus pi over 6. That's our first one. Take away our second one, subbing 0 in. So that's a third. Sine 3 times 0 minus pi over 6. Okay, so we can now, we'll just tidy that up, put an extra bracket on. We can now just evaluate that. So that gives me 1/3. If I take my first one, sine 3 pi over 9. So let's just do this. 3 pi over 9 is pi over 3. So I've got pi over 3. And then our pi over 6, we can think of that as minus pi over 6. Take away a third of sine. And then 3 nothings is nothing, so it's just minus pi over 6. So that gives me 1/3 of the sine of, well, pi over 3 is 2 pi over 6, minus pi over 6 is pi over 6. So we've just got pi over 6 now. Take away a third of the sine of minus pi over 6. So we're going to have to work out what the sine of pi over 6 is. So if you're thinking in degrees, pi over 6 is the same as 180 over 6, which is 30 degrees. So exact value triangles is how I always think of this. So if I got myself a triangle with 2 on this side, 1 on that side, then by Pythagoras, 2 2s is 4, minus 1 is 3, that is root 3. Now that was 60, so that one's 30. The sine of 30 degrees is equal to a half. You might have just memorized that yourself. If you think of a sine graph or a cast diagram, you can see that minus 30 would be about here. It's obviously minus a half for the sine of minus 30 degrees. 1/3 of the sine of 30, so 1/3 times a half, minus 1/3 times minus a half. So a third times a half is a sixth. A third times minus a half is minus a sixth. So plus another sixth because of minus times a minus. That is 2/6. That is 1/3. And we're done there. Getting with a chain rule. SQA Higher Maths 2018, paper 1, question 14. Find the integral between 9 and minus 4 of this function. Going to have to get it ready to differentiate first. So we've got between minus 4 and 9. 1 over. So it's the cube root. So that's to the power of a third. But it's squared, so it's to the power of 2/3. So it's 2x plus 9 to the power of 2/3 dx, which equals the integral between minus 4 and 9, taking it up to the top, 2x plus 9 to the minus 2/3 dx. And now we can integrate it. So we add 1 to the power and divide by the new power, so being very careful, we've got 2x plus 9. Add 1 is a third. Divide by our new power, so divide by a third, but also divide by this differentiated, which is 2. So I can say times 2 on the top bottom as well, and that is between minus 4 and 9, which I'll substitute in when I'm ready. Now this is a non-calculator question, so I'm going to have to put it back into root form as well. So that gives me 2x plus 9 cube root, so I can just write the cube root of 2x plus 9. 2 times a third is 2/3. And that's between minus 4 and 9. Almost done. Dividing by a fraction means we can times it by the reciprocal, flip it upside down in other words. So we get 3 times the cube root of 2x plus 9 over 2. Between minus 4 and 9. And now I'm ready to substitute my numbers in. So substitute 9 in, take away, substitute minus 4 in. So subbing in my numbers, get 3 times the cube root of 2 times 9 plus 9 all over 2. I'll just put that in big brackets. Minus 3 times the cube root of 2 times minus 4 plus 9. I'll just make that clear that that's separate, all over 2. And now we can work some of that out. So that's 3 times the cube root of 2 9s is 18, 18 and 9 is 27 over 2, minus 3 times the cube root of 2 times minus 4 is minus 8, add 9 is 1. All over 2, and that's handy because that now simplifies quite easily. The cube root of 27, 3 times 3 is 9 times 3 is 27. So this just gives me 3 times 3 over 2 minus cube root of 1 is 1. 3 times 1 over 2. That equals 9 over 2 minus 3 over 2, which equals 6 over 2, which equals 3. And we're done there. Equations SQA Higher Maths 2019, paper 2, question 13. A function defined a set of real numbers. It is shown that the rate of change of f with respect to x is given by this equation. The graph of y equals f of x crosses the x-axis 7, 0. Express f of x in terms of x. This question, I suppose, is asking you about do you know what rate of change is? Well, rate of change means differentiation. So we know that f dash x equals 3x squared minus 16x plus 11. So that means that f of x is the integral of this. And we'll get to the second bit of information to get c in a minute. So integrating that, we get x cubed times 3 over 3 minus 16x squared over 2 plus 11x plus c. So there's our initial step. We can simplify that in a moment. But it tells us that the graph of y equals f of x crosses the x-axis at 7, 0. Well, 7 is x and 0 is y. So we can substitute 0 and 7 into our equation. So we've got f of x, tidying it up, equals x cubed, minus 16 over 2 is 8x squared, plus 11x plus c. So when x is 7, y is 0. When x equals 7, y, which equals f of x, equals 0. So subbing that in, we get 0 equals 7 cubed minus 8 times 7 squared plus 11 times 7 plus c. This was a calculator paper, so you could do all the sums in a calculator, but 7 cubed is 343. 7 squared is 49 times 8 is 392. 11 sevens is 77. And then we've got plus c, and 0 equals this. Tidying all that up, we get 0 equals 343 minus 392 plus 77 is 28 plus c, and therefore c must equal negative 28. We've got our c, so we'll just sub it back into the equation we just found above. So therefore f of x is equal to our x cubed minus our 8x squared plus 11x minus 28. And we're done there.
SQA Higher Maths 2025, Paper 1, Question 12. Given the y by dx is 6 cos x plus 8 sine 2x, and y is 4 when x is pi over 6, express y in terms of x. So we're told the differential and told to find y, so it's a differential equation. That means that y just equals the integral of the y by dx, which is the integral of 6 cos x plus 8 sine 2x dx. Now we can integrate that by looking at the start of the exam paper. Cos goes to sine, so that's 6 sine x. Sine goes to minus cos, so that's minus cos 2x. And I've still got the 8, but then you divide by the bit differentiated, 2x becomes 2. So it's over 2 here because of the chain rule. But you've still got plus c as well. Y is 6 sine x minus 4 cos 2x plus c. But when we've got initial conditions, we're told that x equals pi over 6 when y is 4. So 4 equals 6 sine pi over 6 minus 4 cos 2 pi over 6 plus c. Exact value triangle. I think in degrees, and then I turn it into radians. 1, 2, root 3, and that's 30. So pi over 6 is 30. 180 divided by 6 is 30. So that simplifies. And then this fraction here, 2 pi over 6, is pi over 3, which is 60 degrees. And pi over 6 is 30 degrees. So now I've got all my information I need. 4 equals 6. Sine of pi over 6, sine of 30 is 1 over 2. 6 times a half. Minus 4 times cos of 2 pi over 6, which is pi over 3, 60. That's 1 over 2. Plus c. So 4 equals 3 minus 4 divided by 2 is 2 plus c. 4 equals 1 plus c. C equals 3. So we can write our y again with the c back in it. 6 sine x minus 4 cos 2x plus 3. And we're done there.
Differential equations, SQA Higher Maths 2015, Paper 1, Question 15. The rate of change of a mug of coffee is given by this differential equation. It tells you some information. Express t in terms of t. What you need to realise is if you integrate a dt by dt, you just get t back. So we can just immediately say that t equals the integral of the right-hand side, 1 over 25 t minus k. And that will be with respect to t, because it's dt instead of dx as normal. So we'll just integrate and let's go. So we get 1 over 25 t squared, and then we times by a half because we divide by 2. And then minus k times t, but then we've also got plus c. So there is our integral. Let's just tidy that up. Dividing by a half, we get 1 over 50 t squared minus kt plus c. So there's our initial step, but then we need to eliminate that c, but luckily we're given some information. It says initially the temperature of the coffee is 100 degrees, 10 minutes later the temperature has fallen to 82 degrees. Express t in terms of t. So first step, we know that initially when t is 0, the temperature is 100. So we can say that when t equals 0, big T equals 100. Subbing all that in, we get 100 equals 0 minus 0 plus c. In other words, c equals 100. So we've now got t equals 1/50th of t squared minus kt plus 100. But we need to find this k, so we've got an extra bit of information. 10 minutes later, the temperature is 82. So in other words, when t equals 10, big T equals 82. Subbing that point in, we get 82 equals 1/50th of 10 squared minus k times 10 plus 100. So we just need to solve and get k back out. 82 equals 100 over 50 minus 10k plus 100. Just quickly running through this, you get 2 minus 10k plus 100. So you get 82 is 102 minus 10k. Moving the 10k over to this side to make it positive. That is 102 minus 82 is 20. So k is 20 over 10, which is 2. So our final answer is just t is equal to 1/50th of t squared minus 2t, because k is 2, then plus 100. And we're done there.
SQA Higher Maths 2024 Paper 2 Question 7. The diagram shows the curve equation y equals x cubed minus 6x squared plus 11x, intersecting the curve equation y equals 6 plus 4x minus 2x squared at x equals 2, which is here. Now, I've took a liberty shading this in before I filmed this because there was no way that with a scan you could tell what bit you were actually meant to be finding. So it is that purple bit that I've shaded in for you. So we've got two curves. We've got an upper and a lower. So let's identify the curves. This one is above and this one is below. So it's upper minus lower. So it's the integral between 0 and 2, because that's an area. The upper curve is 6 plus 4x minus 2x squared. And we have to take away x cubed minus 6x squared plus 11x dx. So we need to work some of that out. Integral between 0 and 2 then. I've got 6, 4x minus 11x. So 4 minus 11, 4, 5, 6, 7, 8, 9, 10, 11, 6, 7, minus 7x. I've got minus 2x squared minus minus, so that's plus 6x squared. 6x squared minus 2x squared is 4x squared. And then I've got minus x cubed. Now you can rewrite that in a different order if you want, but I don't see the point, so just leave it like that. Now we just integrate 6x minus 7x squared over 2 plus 4x cubed over 3 minus x to the 4 over 4, and we sub in 0 and 2. Okay, so always write your substitution because you get marks at this point. So there's my first bit subbed in with a 2, and then take away 0. Now it is all 0, but I'll write it anyway for the sake of the video. But you should be able to see that we're all x's and zeros, so it's just all that 0. So now be very careful doing it in stages if you have to. So I'm just going to do 6 times 2 is 12. 2 2s is 4, divided by 2 is 2. 2 7s is 14. Now use a calculator anytime you want, but I usually do each term individually. 2 cubed is 8, 8 4s is 32. So that's 32 over 3, which I'll just leave as a fraction for now. 2 2s is 4 times 2 is 8 times 2 is 16. And 16 divided by 4 is 4. So that's my bracket. Take away 0, 0, 0, 0, 0. So we have got 12 minus 14. 12 minus 14 is minus 2. Minus 2 minus 4 is minus 6. So we've got minus 6 plus 32 over 3. And because I can't actually bother get my calculator out, I'll just work that out for you. 6 3s is 18. So that's minus 18 over 3 plus 32 over 3. Now 32 minus 18 is 22, 12, 14. So you get 14 over 3. That is an actual simplified fraction. It's an area, so it's got units and it's squared. And we're done there. 2025, paper 2, question 3. The diagram shows the graph of y equals x squared minus 2x add 3. Calculate the shaded area. Shaded area, the integral between 2 and 4 of the graph then. So it's the integral between 2 and 4 of x squared minus 2x plus 3. dx. Integrate, so add 1 to the power, divide by the new power, minus 2x squared divided by 2 plus 3x between 2 and 4. Simplify, minus x squared plus 3x between 2 and 4, and then sub in. Now, you should just be subbing in, because if you don't show your sub in and then you mess it up, you might lose more marks. So always show your sub in, and then you get a mark at that position, minus a third, 2 cubed, minus 2 squared, plus 3 times 2. I mean, if you can't work out the rest, you're probably going to lose in 1 mark. So 4 cubed is 64 over 3. 4 squared is 16. 3 fours is 12. Minus 2 cubed is 8 over 3. 2 squared is 4. 3 twos is 6. Now, I usually like to work with that calculator as much as I can, just because I'm used to it. So 64 over 3 minus 16 plus 12 is minus 4. And then I've got minus 8 thirds. Minus 4 plus 6 is 2. And then I can take things out that bracket. 64 over 3 minus 8 thirds. Now I've got minus 4 still, then minus 2. 64 minus 8 is 56. So you get 56 thirds, and minus 4 minus 2 is minus 6. So that's 56 over 3 minus 18 over 3. 56 minus 18, well, that gives you 46, 38. So we get 38 over 3 unit squared. Or you can leave your answer as a mixed number if you really want to.
Mr. Clelland here from Clelland Maths. Today we're going to be looking at a paper, 2015, paper 2, question 4 of the SQA Higher Maths exam paper. Let's jump straight in. Okay, this one was about a wall plaque made to commemorate the 150th anniversary of the publication of Alice in Wonderland. Okay, so the edges of a wall plaque are modelled by quadratic functions, and there's 1, 2, 3, 4, and it gives you 4 bullet point equations. So what makes this one difficult is it will give you all these equations, all this information, but you just need to keep your head. So let's look at part A. Find the coordinate of the point of intersection of the graphs of y equals f of x and y equals g of x. So point of intersection means simultaneous equations. So the two ones I need are this one and this one. Since that would equal y and y, so I can just make both of these equal to each other. So to get 1 mark for part A, I'll just do here. I can just write a quarter x squared minus a half x plus 3 equals a quarter x squared minus 3 over 2x plus 5. And that'll give you your first mark. Okay, now we need to solve that to get the x part. And it only asks for the x part, so that's good. Notice if you've got the same thing on both sides, they just automatically cancel. So immediately I can just get like a red pen or something and go, that's the same as that. Same sign and everything, so I can cancel them. I've got minus a half x, so I can add 3 halves x to both sides. And that will get rid of it on this side. So let's just do that and do it in stages. 3 halves take away 1 half is 2 halves, which is 1. So that just gives us x left on this side plus 3 equals 5. And then we can just solve that to find x. Take away 3, so x equals 2. As unlikely as it seems, our answer. Part B says the graphs of f of x and h of x intersect on the y-axis. The plaque has a vertical line of symmetry. Calculate the area of the wall plaque. You should know a power word for integration. is area. So if it says area, you need to integrate and you need to find the two limits. So we've already got our first limit at 0. We need to know this one. Well, this one is going to be the same as this one, which you worked out in part A, where these two intersect, was 2. So that's just 2. So I need to do the integral of the upper f of x minus the lower h of x between 0 and 2. So making sure you copy it down properly, it's the integral between 0 and 2 of f of x, which is a quarter x squared minus a half x plus 3. Put that in brackets. Take away h of x, which is this one, 3/8 of x squared minus 9/4 of x plus 3 dx. So at that point, you may be wondering, well, how much marks do I get? Well, at that point, you get a mark for knowing to integrate, so using the integration sign, just that. Another mark for putting in the limits 0 to 2, and then another mark for writing down the two curves taken away from each other. So 3 marks for literally doing no work. It's not bad, that. And then we need to integrate it, and you actually only get 1 further mark for the integration. So all the tidying up you're going to do now, you're not going to get any marks for, but you still need to do it to be able to integrate. So let's tidy this up. So that gives us the integral between 0 and 2. You've got a quarter x squared minus 3/8 x. So a quarter is 2/8. So being very careful, you've got 2/8 minus 3/8. You've got minus an eighth of x squared. Looking at the x parts, you've got minus a half minus minus becomes plus. So plus 9/4. Well, putting a half into quarters is 2/4. So you've got minus 2/4 plus 9/4 is 7/4. So plus 7/4 x. And then we've got our number parts, but they cancel. 3 take away 3 is nothing. So we get the integral of this between 0 and 2. And then we need to integrate it. So that gives us x cubed. Add 1 to the power and divide by the new power. So 3 times 8 I need to do, which is 24. And then plus x squared. I've got 7 still. But I need to divide by 2. So I've got 4 already on the bottom. So 4 times 2 is 8. And that's between 0 and 2. So that gives us another mark at that point. So let's move on and substitute our limits in. So we've got minus 2 cubed over 24 plus 7 times 2 squared over 8. Take away minus 0 cubed over 24 plus 7 times 0 squared over 8. Okay, so we get a mark for our substitution. And then we need to evaluate it to get another mark. So we could use a calculator at this point because it is a calculator paper, but I'll just go ahead and do it without. So we've got 2 2s are 4 times 2 is 8 over 24, so minus 8 over 24. And then the other number, 2 2s are 4, 4 7s is 28, so you get 28 over 8. And luckily, you've substituted 0 in here, so that is a big fat 0 for this. 0 cubed is 0, over that is still 0, 0 squared is 0, over that is still 0. So you just need to work out these fractions. So I can simplify the fractions. Well, actually, I'll add them first before I simplify because it'll be easier to see. So minus 8 over 24, and then we've got 28 over 8, 8 3s is 24, so times them by 3. I get 3 times 20, so we get 84. So now we can add them. 84 take away 8 is 76 over 24. Simplify that because you have to always have simplified answers. So I'll just divide through by 2 to get 35, 36, 37, 38 over 12. Divide them by 2 again to get 19 over 6. And 19 is a prime number, 6 doesn't go into it, so 19 over 6 is our final answer for another mark. And feel free to do that in any way you want to get 19 over 6, but that isn't the answer. You need to check your question, calculate the area of the wall plaque. Well, we have calculated the area from here to here. So all that bit, if I was to draw a line down here, but you can see it's symmetrical, it even tells you it's symmetrical. So the area of the wall plaque is double the area I just found out. So our final area, just to get our final 7th mark, the area, our like total, equals 19 over 6 times 2. 2 times 19 over 6, well, that's the same as 19 over 3. So 19 over 3 is our final answer for our final last mark. This has been Clelland Maths today. We've been looking at an integration question, quite a difficult one from 2015, paper 2. Take care, stay safe, and goodbye.
The chain rule. SQA Higher Maths 2016, paper 2, question 10. Given it y equals x squared plus 7.5, find the y by the x. And then part B, hence find the integral of this function, which we'll use our answer to part A to do. So part A, the y by the x is equal to, take the half down to the front, x squared plus 7, take 1 off the power, minus a half, and then we differentiate the bit inside the brackets, which is x squared, so that becomes 2x. So that equals 2x divided by 2 is just x, so x bracket x squared plus 7 to the minus a half. And then try to make it look a bit like our part B, that's x over x squared plus 7 to the half, which is equal to x over the square root of x squared plus 7. Part B says integrate 4x over the square root of x squared plus 7, which is very similar. So if I do part B, integrate 4x over the square root of x squared plus 7 dx, well, if I just take that 4 out, I get the integral of x over the square root of x squared plus 7 dx, which I already know is exactly the same as what I found out up here, my differential. This integrated is exactly that. So I can just write the integral as x squared plus 7.5. Simple as that. So that means I've got my answer is 4 times x squared plus 7 to the power of a half. Or, let's make that neater, x squared plus 7 to the half. I've forgot my plus c, so there we are, plus c, and we're done there. SQA Higher Maths 2025, paper 2, question 8. EABCD is a rectangular base prism with AD is shown, DC and DE. Find B to E in terms of IJK. So B to E, where's B? There it is. So I need to get all the way E. So I could go along here. That seems reasonable. So B to C, which is the same as A to D. So let me write that down, 6, 4, 2. I always work in component form and change back. And then I need to go along here, which is the opposite direction of D to C. So minus 2, minus 4, and 2. And then I need to go up here to get to E, which is the same direction as D to E. So plus again, minus 4, minus 3, 4. So I'll work out my numbers. 6 minus 2 is 4. Minus 4 again is 0. 4 minus minus 4 is 8. 8 minus 3 is 5. 2 minus 2 is 0. Plus 4 is 4. So in IJK form, I've got 0i plus 5j plus 4k, which you can just write as 5j plus 4k. And you're done there.
SQA Higher Maths 2018, paper 1, question 12 on vectors, addition and the modulus. Vectors A and B are such that A is this and B is that. Express 2A plus B in component form. So component form is when you've got the brackets. So we've got 2A plus B. Well, that equals 2 times A. 2 4s are 8. 2 2s are 4. And 2 2s are 4 as well. Plus the B, which is minus 2, 1j, and pk. So then we can just add each element. 8 minus 2 is 6. Minus 4 plus 1 is minus 3. And we've got 4 plus p on the end. And we're done there. Part B. B says, hence find the values of p such that the modulus of 2a plus b is equal to 7. Okay. Modulus is the size of, right? So we've got the size of 2a plus b. Well, that equals, it's just Pythagoras, square each numbers and square root. So that's the square root of 6 squared plus minus 3 squared plus 4 plus p squared, and that equals 7. Now, that's a little bit unwieldy what to do with, so just square both sides to get rid of the square root. So that gives us 6 squared plus minus 3 squared plus 4 plus p squared equals 49. Expand the brackets and simplify. 36 plus 9. 4 4s are 16. 4 times p is p, times 2 is 8p. P times p is p squared. That equals 49. Moving everything to the same side and making it look like a quadratic then, because it's got a p squared, we get p squared. And then we've got 36 plus 9 is 45, plus 16 is 55, 61. So plus 61 on the end. And then we've got plus 8p in the middle. And that equals 49. So moving the 49 over to make it a quadratic we can solve. 61 minus 49 is 12. That equals 0. So hopefully that's factorisable. From National 5 Maths, 2 numbers at times to make 12, but add to make 8. That must be 6 and 2, plus and plus. And therefore, p equals minus 2, or p equals minus 6. And we're done there. SQA Higher Maths 2016 Paper 1 Question 7 on vectors. 3 vectors are expressed as follows. I'm not going to read them out, but it then says find f to h and then find f to e. So we can get a handle of what this question is asking us. If I draw a little picture, let's just call this f. I'm going up to g first. So there's g. And then it goes g to h. So let's just call that h. And then it goes e to h. Well, I could go h to e then and just go the other way around for e to h. And then we could kind of complete the picture, I suppose, by saying that there's going to be a vector there. That's going to be my f to e. I have to find that one. So that's part B, say. And I have to find f to h, which is along the middle. So that's my part A. So we know, remember, all the solid lines. So for part A, f to h is equal to, let's just trace this out to make sure we don't make any mistakes. What I get from f to h, so I just go f to g plus g to h. F to g plus g to h. Now I find writing the vectors in this form easier, so f to g is minus 2 minus 6, 3, plus g to h is 3, 9 minus 7. Adding them together, minus 2 plus 3 is 1. Minus 6 plus 9 is 3. And then 3 take away 7 is minus 4. So we get 1, 3 minus 4. Just writing that in the same format as the question. That's I plus 3j minus 4k. And we're done there. Part B, find f to e. So we want to get from here to here. We can't go that way. So we can go any way we want, remember. So we can just go that to that and then that. But we might as well just go straight across now, because we know that. And then go down. So it's f to h plus h to e. F to h plus h to e. Well, we know f to h, we just did it. 1, 3 minus 4. Plus h to e, well, it tells us e to h. So h to e is just the minus of that. So it's minus 2, minus 3, minus 1. Minus 2, minus 3, minus 1. 1 minus 2 is minus 1. 3 plus minus 3 is 0. And minus 4 plus minus 1 is minus 5. Or writing that out, minus I minus 5j. And we're done there.
SQA Higher Maths 2025, Paper 2, Question 5. Show that the points are collinear and then find the ratio that b divides a to c. So for collinearity, I do a to b, which is b minus a. So that is 6 minus minus 3, which is 9. Minus 1 minus 2, which is minus 3. And 5 minus minus 1, which is 6. And then we do the same for b to c, which is c minus b. So that is 12 minus 6, which is 6. Minus 3 minus minus 1, which is minus 2. And 9 minus 5 is 4. So we get 6, 2, 4, and 9 minus 3 and 6. So 6, 12, 18, 9, 18. The lowest common multiple between, say, 9 and 6 is 18. So if I just times that by 2, that equals that times 3, hopefully. So let's just check. 2ab hopefully equals 3bc. So they're multiples of each other. 9, 2 9s is 18, 2 3s is 6, and 2 6s is 12. 3 6s is 18, 3 2s is 6, 3 4s is 12. So we get the same. And therefore, we can then say that A, B, and C are parallel, but B is a common point. So A, B, and A, B, C are collinear. And now says state the ratio that B divides AC. Well, this is easy now. If you've written it like this, 2AB equals 3BC, then you just want AB over BC, and that's the fraction. Well, AB over BC is just 3 over 2, and that means that our ratio is simply 3 to 2. And we're done there. SQA Higher Maths 2024, Paper 1, Question 4. P and Q have these coordinates, and R divides PQ in the ratio 2 to 3. Find the coordinates of R. So we've got a picture, I suppose, like this, and we've got a P down here and a Q up there. We've got R somewhere there, and the ratio is 2 to 3. So a quick and easy way to remember this is that 2 times that equals 3 times that. It's as simple as that. So we can just write 2 of RQ equals 3 PR. Now where does that come from? Well, it really comes from the fact that PR over RQ is 2/3. So you get there quite quick, and then you can expand and simplify. Now there is some tricks that some teachers teach where you do something about adding the coordinates and dividing. So you can say that at this stage, if you remember that trick, it's 2q plus 3p all over 5. That is a quick way, but I never do the quick way. Do maths properly. So we've got 2q minus r equals 3r minus p. So that's 2q minus 2r equals 3r minus 3p. And I want r, so I'll take r's over to this side to get 5r. And then the q and the p is going to be over here. And that's your 2 and 3. So you've got 2q plus 3p all over 5 equals r. Like again, you could have seen that from this kind of pattern, 2q, 3p over 5. So then we just put in what our numbers were. So q was minus 1, 11 and minus 8. So that's 2 minus 1, 11 minus 8 plus 3 minus 6, 1, 2. All over 5. So that gives me minus 2, 22 and minus 16 plus 3 6s is 18, 3 1s is 3 and 3 2s is 6, all over 5. Finally, that gives me minus 18 minus 2 is minus 20, 22 plus 3 is 25, minus 16 plus 6 is minus 10, all that divided by 5 is final answer of minus 4, 5 and minus 2, and we're done there. So we can then say that that's r. So our coordinate r to answer the question is minus 4, 5 and minus 2, and we're done there. SQA Higher Maths 2019 Paper 2 Question 3 on vectors and vector pathways. It says EABCD is a rectangular based pyramid. It tells you that A to B is P as shown, A to D is Q as shown there, and A to E is R. And we have to express B to E in terms of P and R. So where's B to E? I need to start here and get up to there. So remember, you can take any direction you want. So I can just trace this. I go minus P. So I can write minus P. I've done minus P, and I want to get all the way up to E. So I can go up R, so plus R. And that's it. It really is as simple as that.
Point F divides BC in the ratio 3:1. Express the vector EF in terms of P, Q and R. So EF, just to be clear, is from here down to there. I want to get to there, but I need to go a path that I can actually use. So we could go along there, down there, and then back to there, and that will give me that. So let's just trace that out. I've got minus R plus P. So let's write that down to start with, minus R plus P. And then once I've done minus R plus P, I need to go along here. You know, how far along am I going? Well, it says it divides it in the ratio 3:1. So if I imagine that this whole length is 4, I've went along 3 out of 4 bits. 3/4. And what is B to C's vector? Well, it's the same as this one because it's parallel. So it's 3/4 of Q. So plus 3/4 of Q. And we're done there. SQA Higher Maths 2019, paper 1, question 9 on vectors and scalar product. Vectors U and V have V's components, where P is a member of the real numbers. Find an expression for U dot V for part 1. Well, U dot V is told to you at the start of the exam paper. If you forget, it's either got an angle in it or it is times each element, then plus the second element, then plus the third element, all times together. So I can just write that down. I've got P times 2P plus 16. Plus minus 2 times minus 3 plus 4 times 6. So then we can just simplify that, expand my bracket, I get 2p squared plus 16p plus 2 3s are 6, minus times a minus is a plus, 6 4s is 24, so that's 2p squared plus 16p plus 30 is our simplified U dot V. Part 2. Determine the values for P for which U and V are perpendicular. Well, if U and V are perpendicular, that means that U dot V equals 0. And why is that? Well, if you look at the start of the exam paper, you're given the formula sheet, which says that U dot V is also the size of A times the size of B times the cosine of theta. Now, if theta was 90, cosine 90 is equal to 0, so U dot V is 0 when they're perpendicular. But you could just memorize that. So U dot V equals 0 means I can write 2p squared plus 16p plus 30 equals 0. Take 2 out as a common factor. P squared plus 8p plus 15. So that's a quadratic. So from National 5 Maths, I'm looking for double brackets probably. Two numbers that times together to make 15, but add together to make 8. Well, that's 5 and 3. So it's plus 5 and plus 3. So that means that P plus 3 equals 0 or P plus 5 equals 0. Solving both of the equations, we get P equals minus 3 or P equals minus 5. And we're done there. Part B says, determine the value of P for which U and V are parallel. So if a parallel, that means that I can times this one by something to get this one. So let's just compare the elements. I've got minus 3 over minus 2, that's 3 halves. And similarly, I've got 6 over 4, which is also 3 halves. That means that if I times this one by 3 halves, I get this one. So I can just write that down. 3 halves of P equals 2P plus 16. So for part B, 3 halves of P equals 2P plus 16. So I've got that equation to solve. So if I put brackets around that side, that means I can times by the bottom. So 3p is equal to 2 times 2p plus 16. 3p equals 4p plus 32. So taking it over to the other side, you would get minus p equals 32 or p equals minus 32. And we're done there. SQA Higher Maths 2024, paper 2, question 3. The coordinates D, E and F are given by these 3D coordinates. Express E to D and E to F in component form, and then calculate E to D dot E to F and find the angle. Oh, that's nice. We're doing it in bits away. So let's do E to D. So remember, that's just D minus E. So D is 2 minus 3 and 4. And E is 1, 1 minus 2. Taking them away and being careful not to mess it up. 2 minus 1 is 1. Minus 3 minus 1 is minus 4. And 4 minus minus 2 is 6. So there is E to D. Same for E to F. F minus E, that is. So we've got 3, 2, 1. Minus 1, 1 minus 2. 3 minus 1, that's 2. 2 minus 1 is 1. 1 minus minus 2 is 3. So that's us done part A. Part B, part 1, ed.ef. So we've got to do ed.ef. So ed is 1 minus 4, 6. I have to dot that with 2, 1 and 3. So that's 1 times 2 plus minus 4 times 1. Don't know why I'm writing a plus sign here. Plus 6 times 3. 1 times 2 is 2. Minus 4 times 1 is minus 4. 6 3s is 18. 2 minus 4 is minus 2. Minus 2 add 18 is 16. So we get 16. Hence, always calculate the size of angle DEF. Well, let's just check it. We're not trying to trick us here. We've got E to D, E to F, say. So, yep, I think that's okay. So, we're just doing the angle in between. So, from the start of the exam paper, if you just look, you get A dot B equals size of A, size of B, cos theta. So, just slightly rearranging that, cos theta is A dot B over size A, size B. So for this example, cos theta is, we've got ed dot ef, all over the size of ed and the size of ef. So that is just 16 over something. So I need the size of ed. So let's look at ed again. ed is equal to 1 minus 4 and 6. So the size of that is just Pythagoras, square root, 1 squared plus minus 4 squared plus 6 squared. That is 6 6 is a 36, 4 4s is 16, 36 and 16 is 46, 52, plus 1 is 53. So you get root 53 for that one. And then EF, remember, we had 213. So the size of EF is just equal to the square root of 2 squared plus 1 squared plus 3 squared. 2 2s is 4, 3 3s is 9, 4 and 9 is 13, and 1 is 14, I think. So we get root 14. So that means that our cos theta is equal to 16 over root 53 root 14. So now it's a calculator job to get theta. Theta is the inverse cos of all of that nonsense. 16 over root 53 root 14. Shift cos 16 divided by open bracket root 53 times root 14. I get 54.028. Or if you want to round it, degree sign anyway, 54 degrees would be perfectly acceptable, I think there. 52.03, 52. Who cares almost? And there we are, we're done there.
SQA Higher Maths 18 Paper 2 Question 8 on the vector scalar product. U and V are defined as V's vectors. Find U dot V. Start of the exam paper tells you what U dot V is. You times each element and you add. So U dot V is equal to minus 1 times minus 7 plus 4 times 8 plus minus 3 times 5. That gives us 7 plus 32 minus 15. 7 plus 32 is 39. 39 minus 15 is 24. Okay, part B. Find the acute angle between U and V. So again, the start exam paper, A dot B is equal to the size of A plus the size of B times the cos of theta. So we know the size of, we know the A dot B, so we need to find the size of U and V. So the size of U is equal to the square root of minus 1 squared plus 4 squared plus minus 3 squared. Minus 1 squared plus 4 squared plus minus 3 squared. That's the square root of 1 plus 16 plus 9. That is 26. And then the size of v is equal to the square root of minus 7 squared plus 8 squared plus 5 squared. (49 plus 64 plus 25. Use the calculator anytime you want. That's 138. So that means that u dot v is equal to, we know that's 24. So 24 equals square root of 26, square root of 138, cos theta. So rearranging for cos theta, that means that cos theta is 24 over the square root of 26 times the square root of 138. So our theta is the inverse cos of all that. So we just get a calculator and work it out. So the inverse cos, 24 over root 26 times root 138. That gives me an answer of 66.38. So theta equals 66.34 degrees. And we're done there.
SQA Higher Maths 2025, Paper 1, Question 10. The vectors u and v are such that u is 110, v is 13k. The angle between them is 45. Find the value of k. So a question like this, you're looking at u dot v. And there's two ways to do u dot v. The first way is to times the vector's components together. So the top numbers, 1 times 1, plus the middle numbers, 1 times 3, plus the bottom numbers, 0 times k. So I'm going to start for there. That gives me 1 plus 3 plus nothing, which is 4. So I actually now know that u dot v is 4. But the other formula is u dot v equals the size of u times the size of v times the cos of theta. Well, I know the size of u, size of v, and cos of theta, and I know u dot v is 4, so it's pretty simple now. I don't know the size of u and v, but I can work it out actually. So the size of u is the square root of 1 squared plus 1 squared plus 0 squared. That's root 2. And the size of v is the square root of 1 squared plus 3 squared plus k squared. I can't do much with that, so that's 3 3s is 9 and 1 is 10, 10 plus k squared. So I'll just keep it, it's fine, it's about algebra. So u dot v is uv cos theta, root 2, root 10 plus k squared, cos theta, and theta it told us was 45 degrees, and that all equals 4, because I just worked out u dot v was 4. Exact value triangle, 45, 1, 1, root 2. Cos of 45 is 1 over root 2. So that gives us root 2, root 10 plus k squared, 1 over root 2 equals 4. So v root 2's just cancel. So straight away I get root 10 plus k squared equals 4. Well, to get rid of a root, you can do the opposite, which is squaring. So if I square this side, I get 10 plus k squared. If I square that side, I get 16, 4 fours. Quadratic, it's not even a quadratic. I can just take the k squared there and do 16 minus 10, which is 6. And that means that k equals the square root of 6. So what was the question? Find the value of k where k is greater than 0. Okay, it says k is greater than 0, so k is just root 6 as k is greater than 0. In other words, not minus root 6. And we're done there. That was the Ultimate Higher Maths 2026 exam prep video. Hopefully you found it useful. Remember, get it on the app.clellandmaths.com, and don't forget to join those epic last-minute live streams the night before the exam. Easter study sessions for bonuses as well. Get on it. Make sure you keep studying. I'll be getting lots more content out before the exam. Take care, stay safe, and I'll see you soon.